everyone and welcome back to my channel. In today's video, we are going to solve 15 plus SQL questions that are asked in companies. Now, these questions are from top companies like Uber, Swiggy, Zomato, Walmart, Amazon, Microsoft, and so on. And for each question in this video, we are going to understand first the problem statement, followed by the output explanation, the problem solving approach, and the steps that we need to follow to actually write the SQL query. And finally, we'll be writing the SQL query in MySQL Workbench along with the complete explanation of the SQL query. So let's start solving the problems together.
This question is based on retrieving the third transaction of every user from an Uber transaction table. So let's understand the question here. So just assume that you are given a table named transactions which contains Uber transactions made by the users, and the table has three columns. The first one is the user ID. It is nothing but the unique identifier for each user. The second one is the spend, which denotes the amount spent on the transaction, and the third one is the transaction date, which is nothing but the date and time of the transaction made by the user. So this is how your table looks like. It contains three columns: user ID, spend, and the transaction date. Now you have to write a SQL query to obtain the third transaction of every user, and the output should contain the user ID, spend, and the transaction date. So now in this question, you have been asked to find out the third transaction of every user. So let's understand with the help of input and output tables here. So in the input table, since we already discussed, we have three columns: user ID, spend, and the transaction date. So if we see for the user ID 111, which is this one, 111, it has three transactions, which is made on the date January 8, 2022. This is the second transaction was made on 10th January 2022, and the third transaction was made on 5th February 2022. So now we can clearly see that this is the user ID which contains three transactions, and the other user IDs which are 121 and 145. So these two user IDs have only one transaction which is made here on these particular dates. So we can see that user ID 121 and user ID 145 each have one transaction. So now what would be our output? So our output would be the user ID 111. This is because the user ID 111 appears in the output because that is only the user in the sample data with three or more transactions. And the output would look like this. It would contain the user ID, which is 111, which made the transaction on 5th February. So here is the date, and the amount, the spend amount made by the user ID 111. So this is how our output would look like. So now the question is, how will we find the user details who made the third transaction? So in this case, we just have to display the third transaction of each user. So now to do this, we will make use of window function, and just what we will do is we will make use of row number function, and this function actually helps us to assign a unique sequential integer to rows within a partition of a result set. So in this case, we will have to partition will be done on the user ID column, since we want the every third transaction of the each user. That means the partitioning will be done on the user ID. Okay, and then we have to find the third transaction. That means the order by clause will be done. The order by clause will be applied on the transaction date column, so that we can just order the transactions, and then we can just retrieve the third transaction over there. So now let's write the query on MySQL Workbench, and there I'll explain you the solution step by step. So let's get started. So guys, here I have imported my transactions table. If I run this, I'll get my table here which contains three columns, and now we have to write a query to find the third transaction of each user. So now to do that, since we already discussed that we will make use of window function, that is the row number function. Why? Because the function helps us to assign a unique sequential integer to rows within a partition of the result set. In this case, we will do the partition on the user ID, since we want to find the third transaction of each user. So we will do the partition clause partition by clause on the user ID, and using the row number function, we will be able to assign the number of transactions made by each user. So first let's write that. So in this case, I just want to retrieve all my columns along with my new column, which is nothing but which will indicate the transaction number for each user. So I'm assigning the row number over partition by, since I want to, just a second guys, partition by, so I want to retrieve for each user, so I'll just do the partition by clause on the user ID. Next, why it is not valid? Partition by, okay, user ID, and I'll do the order by on transaction date. Okay, so this will be on this, yes. Okay, so this will be the transaction number of each user. Okay, so this will give us the transaction number of each user, and I want it from my transactions table. So if I just run this query, what I would get is, so for the user ID 111, we can see that this is the transaction number 1, this is the transaction number 2, and this is the transaction number 3. Okay, and what do we want is, we want a third transaction of each user. So now what do we want in our output? So let's make this, just make it as a temporary table, and just give it as X. So from this table, so just writing it from X. So from this table, I just want to retrieve my columns, that is the user ID, the spent, and the third one was the transaction date, because these are the only columns which I want in my output. I don't want this column to be in my output, so that's why I made this as a table from which we want to retrieve our records. So where, and since we want only the third transaction, so I'll just do X dot transaction number from this column. This column should be 3. So what it will give me, it will only give me the details of the users whose transaction number is nothing but 3. So if I just run this query, what I will be getting is, I got my final output, which is the user ID 111, and its third transaction details here. So again, I will just break down the solution here. What I did is, I just applied the window function, which is a row number function, to create a new column, which is nothing but the transaction number column, and this column assigns a unique sequential integer to each transaction within the user ID partition and order by transaction date. And that is what we wanted. We wanted to identify, we wanted to extract the third transaction made by the user. So to order the number of transactions, to order the transaction dates, we just made the order by clause on the transaction date. So this is done in the ascending order, and the partition by user ID, because we wanted it for each user. So this has given us the transaction number. Now what we wanted is, we just wanted to extract the user ID, spend, and transaction date, these 3 columns. So based on the condition that the transaction number should be 3, because we just want to extract only the third transaction. So I just wrote this condition in my where clause. I just made it as a subquery, and from this subquery, I have just extracted these 3 columns, and with the condition that this condition filters the rows to keep only those where our transaction number is equal to 3. That means we are selecting only the third transaction of each user. So I hope you are clear with the solution. If you still have doubts, please let me know in the comment section, so that I can answer your queries there. And also, if you guys think that there can be another possible approach, or that you might have another alternate solution, then please let us know your solution in the comment section, so that others can just make use of it. So the question is about correcting a swapping error in Zomato's order database. So just imagine that Zomato encountered an issue where each order item was mistakenly swapped with the next one. And our task as a data analyst is to fix this error and ensure that every order ID is paired with the correct item. Also, if the last item has an odd order ID, it should remain as it is. That means the last item should remain as it is in the corrected data. So let's see the example of the incorrect data and the corrected data. That means the input table and our output table. So for the input table, the table name is orders. We have two columns, order ID and the item, respective item of the order ID. And in the output table, we again have two columns, that is the corrected order ID and the respective item of the corrected order ID. So you can just pause the video here and take a snapshot of the input and output table to just see how order ID is paired with the wrong item and how the output table shows the corrected order of the items that match their intended order IDs. So if you clearly see for the order ID 1, since it was referring to chow mein and the order ID 2 was referring to item pizza, in the input table and in the output table you can see that the order ID 1 is now referring to pizza and the order ID 2 is now paired with chow mein. That means they have swapped the items. Similarly, if you see for the order ID 3 and order ID 4, since in the input table the order ID 3 has been matched to veg nuggets and the order ID 4 has been paired with paneer butter masala, but if you see in the output table the order ID 3 is now paired with paneer butter masala and the order ID 4 is now matched with veg nuggets. Similarly, the items have been swapped for order ID 3 and 4. Similarly, if you see for the 5 and 6, it has happened the same. The items have been swapped, but if you see for the order ID 7, that is the last order, it has the odd order ID. Since 7 is the odd number, it should remain unchanged. So in the example in this case, the last item of the order ID is paneer tikka, and since it has remained same as the order ID 7 in the corrected data. So I hope you are clear with the input table and the output table now. So now let's just think through the solution approach. What would be the methodology to write a SQL query for just correcting this orders data? So what can be the approach? You can either think through it. So in the next slide, we will just discuss about the solution steps. So let's move on to the solution steps here. So our step 1 would be to write a CTE to count total number of orders. So first you need to determine how many orders are there in the orders table. So since this is important, because whether there is an odd or even number of orders will affect how you apply the swapping logic in the next step, or probably in the further step. Now let's move on to the step number 2. So in this step, we will just integrate the output of the first CTE in the main query using cross join. So in this step, we will just perform a Cartesian join, which is nothing but the cross join between the orders table and the CTE that we just wrote in the step 1. So this join will pair every row in the orders table with the single row of the CTE. Now in the third step, we will just apply our swapped order logic with case statement. So finally in this, we will correct the order IDs to match the corrected items. So you will use a case statement to apply the swapping logic here. And in the final step, we will just sort the results, that is by the corrected order IDs. So this is how we are going to approach our question here. So let's now move on to MySQL Workbench, where we will just write a query as we discussed in the steps here. So let's start. So guys, as you can already see that I have imported my input table, which is the orders table containing two columns, order ID and item. And since we want to swap the items of order ID 1 and 2, similarly for the order ID 3 and 4, similarly for the order ID 5 and 6, and for the order ID 7, the item is going to be same since it is the odd order ID. So I hope the output picture is very clear in your mind. For the order ID 1, we are going to have the item pizza. For the order ID 2, we are going to have the item chow mein, just swapping the items of the order ID 1 and 2. Similarly, for order ID 3, our item is going to be paneer butter masala, and for order ID 4, our item is going to be veg nuggets. Similarly, for 5 and 6, for 5 the item is going to be veg burger, and for 6 the item is going to be spring rolls, and for the 7 the item is going to be the same. So to do that, since we already discussed the steps to follow, so our first step was to find the total count of orders. So we'll just write a CTE to find the total count of orders. So let's just write a query to find the total orders count. So I'll just write my query, and to do that I'll make use of the count function. So to do that, the count of order ID, it will give me the count of total orders. So I'm just giving the alias to the column as total orders. So if I just run this query, I get my total orders as 7. So I'll just make it as my CTE with order counts as. So I'm just making it as my CTE. So this has become my CTE now. Now my next step was to integrate this CTE with my orders table that I have. So to do that, we will just perform the cross join between the orders table and my order count CTE that I just wrote it now. So this join will pair each row in the order table with the single row that contains the total number of orders. So let's just write that. Select star from, which is my orders table, and I will just do cross join with my order counts. Okay, so let's now run this query and see what it gives us. So it has given me total orders for the order ID 1, item chow mein, and the total orders. So we can see that every column of this CT has been matched with the columns of the orders table. So now comes to our third step, where we will be applying the swapped order logic using the case statement. So if you clearly see, for the order ID column, we are going to apply the case when statement in the order ID column here. We are going to keep the item column as it is. Only changes will be made to order ID column. So since we have to pair the order ID 1 with the item pizza, to do that we will have to do +1 to this order ID. Similarly, if we want to pair for the order ID 2 with the chow mein, we will have to do -1 to this order ID. So 2 minus 1 will become 1, and the order ID will be matched to item chow mein. Similarly, if we see for the 3 and 4, for the order ID 3 to be matched with the paneer butter masala, we will have to do +1 to this, and for 4 we will have to do -1. Similarly, for 5 we will do +1, and for 6 we will do -1 to just match it. So now there is a pattern which is following is, if the order ID is odd, we will do +1, and if the order ID is even, we will do -1 to the initial order ID. So for the 1, 3 and 5, we just have to do +1. For 2, 4 and 6, we have to do -1. So let's now write our swapping logic that we just discussed. So here I'll just write it in this query only. So in this query, I just corrected order ID. So I just removed the order ID column here. So I'll just apply the case when statement. Case when. So when my order ID is odd, that means it is not divisible by 2. So the order ID is odd. That means it is not divisible by 2. So I'm just writing it like this. So this statement shows that my order ID, if not divisible by 2, that means this order ID will be odd.
And also my order ID should not be equal to total orders. That means it is not my last order ID. Okay. And my order ID should not be equal to total orders, because for the last order ID we have another condition. So my order ID should not be equal to my total orders. Then in this case, then in this case, okay, I'll just write it here. Then in this case, my order ID will become plus one, sorry. Okay. Now what if my order ID is equal to total orders? That means that is my last order ID. So in this case, since order ID 7 is equal to total number of orders, that is 7. This is my last order ID. So in order to do that, we have to keep it as it is. If in case it is my if it is my last column, I have to keep it as unchanged. So let's write the situation for that as well. Since my order ID has to be odd, so I'll write the same thing is equal to 0, and order ID should be equal to total orders. Then it is going to be order ID, which is the same. And at the last we can just write our even number wala condition. So that will be, we can also write it using else it will be order ID minus 1. We don't really need to write the entire thing, because if this is the case, then it will be, if for the first case it will be order ID plus 1, for the second case it will be order ID, and the last case would be that only, that our order ID is even. So we just wrote it with the else, and later on we can just give it as the column alias of this column to be corrected order ID. So I have applied the swapping condition to my this order ID column. Okay. And the second column that I want to retrieve is the item column as it is, since we were not going to make any changes to this. And so this is my second column that I'm going to retrieve. And at the last, I just wanted to sort my result with the corrected ID. So I'm just doing order by with my corrected order ID column. So this is my final query looks like. This is how my final query looks like. If I just run my complete query, now I can see that I have got the output, which is my corrected order ID got matched with pizza, chow mein, paneer butter masala, veg nuggets. That means my items have got swept. So if I see my input table here, so this was my input table: chow mein, pizza, veg nuggets, paneer butter masala, spring roll, veg burger, paneer tikka. If I see my output table, so this is how we can see that the items have got swept. So this is the swapping logic that we applied on the order ID column here, and we just named it as corrected order ID. So this was the center part of this question. So I hope you understood how to write the swapping order and how to get the output just like this. The question is on calculating the difference in the number of credit cards issued each month. So let's understand the problem statement here. So imagine that your team at JP Morgan is preparing to launch a new credit card, and to gain some insights, you're analyzing how many credit cards were issued each month. So your task is to write a query that outputs the name of each credit card and the difference in the number of issued cards between the month with the highest issuance cards and the lowest issuance. At last, you just need to arrange the results based on the largest disparity. So you have been given a table that contains 4 columns: card name, which is nothing but the name of the card; issued amount is the number of cards issued in a given month; issue month
is the month in which the cards were issued. Issue year is the year the cards were issued. Now our goal is very simple, since we just need to find the difference between the month with the highest number of cards issued and the month with the lowest number of cards issued for each credit card. So the final output should show the card name and the calculated difference sorted from the largest to the smallest difference. So that's how your output should look like. It should have two columns, card name and the difference, which is nothing but the calculated difference between the highest number of cards issued and the lowest number of cards issued for each credit card. So let's now move on to understand the calculation behind this output table that you just got derived from the input table. So in this case, from the sample input table, we can see two cards. The first card is Freedom Flex card and the second card is a Fire Reserve card. So for the Freedom Flex cards, you can see that the issued amount across months are, for the month of January, we can see that the issued amount is 55,000. For the month of February, we can see that the issued amount is 60,000. For the month of March, it is 65,000, and for the month of April, it is 70,000. So we can say that the maximum issued amount is 70,000 and the minimum is 55,000. So the difference between the maximum and minimum will come out to be 70,000 minus 55,000, and that will give us 15,000. Now coming to the second card, that is Sapphire Reserve card, the issued amounts you can see from the input table are, for the month of January it is 1,70,000, for the month of February it is 1,75,000, and for the month of March it is 1,80,000. So in this case the maximum issued amount is 1,80,000 and the minimum is 1,70,000. So the difference between both of them will come out to be 10,000, that is 1,80,000 minus 1,70,000, that will give us 10,000. So that's our output. As you can see from the output, the card name for the Freedom Flex card, the difference is 15,000, and from this Sapphire Reserve card we can see that the difference is 10,000 that we just calculated now. So alright, you're clear with the sample input table and the sample output table. Now let's move on to writing the SQL query and what would be the solution steps to solve the problem. So basically, to solve this problem, our first step would be to find the highest and the lowest issued amount for each card. So in this case, we can just make use of max and min function to calculate the maximum and minimum number of cards issued in a month. Now the step 2 will be to subtract the minimum from the maximum to find the difference in the card issuance. The third step would be to group the results by each unique card name. Since this is essential because we want to calculate the maximum and minimum values per credit card and not across all the cards. Now coming to the last step, we just need to order the results by the difference starting from the largest one as requested in the problem statement. So that's how we are just going to approach this problem. Let's now move on to my SQL workbench to implement these steps. So guys, here is my input table, monthly cards issued. If I just run this, you can see that these are the rows and columns that I have in my input table. Now since I've been asked to calculate the difference between the highest number of card issued and the lowest number of card issued for each card type. So let's write the SQL query implementing the steps that we just discussed. So first of all, I'll just make use of min and max function to find out highest and lowest number of cards issued. So here I'm just going to write select and since I want to make sure that card name should be there in my output, so I'm just writing the card name. Next, I will just make use of max function on the issue amount column, issued amount column. So it will just give me the max, and since I just want to calculate the difference between min and max, so I'm just writing the subtraction sign here and min of issued amount. Since this was our second step, that we just want to subtract the lowest value from the highest value to get the difference, so that's what we just did. So it will just give us difference. Now this is from my table name, that is monthly cards issued. Okay. And now also we just need to apply the group by clause on the card name. That is because we want to calculate the maximum and minimum values per credit card and not across all the cards, because we want to mention for each card name we want to find the difference between the highest issued amount and the lowest issued amount. At the last we just have to do order by on the difference. That has to be in descending order since we want to display the highest amount first and then followed by the lowest amount. So that's how about my SQL query. If I just run this query, I will be getting the desired output. So if we just understand the query again, we have just make use of max function to give us the max highest number of cards issued for that particular card name. Then we have used min function. Similarly, this will give us the lowest number of cards issued for that card. We are just using a subtraction sign to calculate the difference between the max and minimum, and this will just give us the difference. Then we are doing group by clause to make sure that we are just calculating the results for each unique card names, since that is what we are expected to do. At the last we are just doing the order by clause on the difference, that too in the descending order, to make sure that our results are sorted from the largest difference to the smallest difference. So the problem is on finding 3 months moving average of revenue. So this problem will also help you understand how to calculate sales trends over time. So let's move on to the problem statement here. So assume that you have been given two tables. One is the customers table and the other one is the orders table. So for the customers table, you can see there are three columns. The customer ID, which is the unique identifier for each customer. Name is the name of the customer. And join date is when the customer got joined. Now for the orders table, you can see there are four columns. Order ID is again the unique identifier for each order. Customer ID is the ID of the customer who placed the order. So order date is the date of the order and amount is the order amount in dollars. Now you have to calculate the 3-month moving average of sales revenue for each month using the sales data in the orders table. Also, the moving average should start calculating once 3 months of data are available, providing insight into average sales trends over time. So let's take a look at the input table and the output table over here. So these are your input tables, the customers table and the orders table. And this is how your output table should look like. It has three columns: month, monthly sales, and the moving average sales of the 3 months. Now let's understand how this output table just got derived from these input tables. So to derive this output table, first of all, we will have to calculate monthly sales. So to do that, for each month, we will calculate the total sales using sum function on the amount column. So for the monthly sales calculation for each month, we are just making use of sum function on the amount column to calculate the total sales. So if you see for the January month, so for the January month here, for the order date, if you see, there is one column for the January month, two columns for the February month, one column for the March, then one for the April, one for the May, and another one for the June. So let's just calculate the total sales amount for each month. So for the January month, the total sales amount is 100. For the February month, the total sales amount is going to be 150 plus 200, that is 350. For the March month, it is going to be 300 as it is, since we have only one row for this. And similarly for the April, May and June. So the monthly sales calculation will something look like this. It should have month. So this is the January month having monthly sales 100. For the February month, it has 350. For March, it has 300. For April, it is going to be 250. For May, it is going to be 400. And for June, it is going to be 350, because we don't have more rows to calculate the sum. So that is going to be the sum, the total sum for that particular month. So once we have just calculated our monthly sales, so let's move on to calculate the 3 months of moving average. So to calculate the 3 months of moving average of sales revenue, we need to consider the current month revenue and the revenue of the two preceding months. So the 3-month moving average for a given month will be calculated as follows. So revenue of current month plus revenue of previous month and plus the revenue of the month before previous month divided by 3, since we want to compute the average. So let's just calculate starting from March. So since we have been given that the moving average should start calculating once 3 months of data are available, and here the 3 months of data is available starting from March. So for the March of 2023, moving average sales will be calculated as the average of January, February and March, which will come out to be 100 plus 350 plus 300 divided by 3, and it will be around 250. Now for the month of April, it is going to be the average of revenue of February month, March month and April month, and it will be 350 plus 300 plus 250 divided by 3, that will come out to be 300. Now for the month of May, it is going to be the average of March, April and May. So it will be 300 plus 250 plus 400 divided by 3. So this is how it is going to be for that will be 316.67. And for the month of June, it is going to be the average of April, May and June, which is 250 plus 400 plus 350 divided by 3, that is 333.33. So I hope you are clear with the output, like how the output has just got derived. So let's move on to writing the SQL query to get this expected output. So what would be our approach? Let's discuss that. So here is how we are just going to approach our solution using SQL. So our step one would be to calculate the monthly sales as we just did. So first of all, we will just write a CT to calculate the monthly sales. We will be using date format on the order date column. So it will just extract just the year and the month from the order date. And then we will just group by this month column, and we will just use the sum of amount to get the total sales per month. In our second step, we will be just calculating the 3-month moving average using window function. So here this average is computed by taking the current month sales along with the sales of the two previous months. So we will be using average function with the window function to achieve this. And in my last step, I will be just sorting my results by order by month. So it will just give my results in the chronological order, so that will ease in my analysis. So let's move on to the implementation part over here. So guys, as we discussed, here are my input tables, the customers table and the orders table. So this is my customers table and this is my orders table. And since I need to calculate the 3 months of moving average, so as we discussed, our first step is going to be to calculate the monthly sales. And to do that, we will be writing a CT. So let's create a CT to calculate the monthly sales totals. So I'm just performing. So I'm just giving the CT name as the monthly sales as, and here I'm just going to write my query. So whatever the columns that I want to retrieve, I'll just retrieve it out afterwards. So this I'm going to take from my orders table. So as I said, here we will be using date format function on the order date column to extract just the year and month from the order date, because we don't need the exact date. We are only dealing with the month and the year. So to do that, let's just make use of date format. So date format on order date column, and I just want to format it as year dash month. I just want year and month. So this will just give me month. Okay. So okay, this has to be single. Yeah, fine. Now since I want to calculate the sum of amount to get the total sales per month, so here I want to use sum on my amount column, amount
amount column. So it will just give me, so what it will give me as the monthly total sales, let's say. But monthly sales is something that is in my output table. So this is my monthly sales. I have to put comma over here. And since this is my aggregate function, I have to apply the group by function on this thing. So I'm just doing group by on my date format. So all the non-aggregated rows has to be in group by function, as we already know. So this is my CT that I just wrote here. Just as month. Okay. So this is my CT that I just wrote. If I just run this CT, I should be getting. So as you can see that we have got our result here. We have two columns, month column and the monthly sales column. So the month column denotes the respective month. So as you can see, we have got for the January month it is 100. For the February month, as we discussed, it is going to be 350, which is nothing but 150 plus 200 for the February month, and so on for the March, April, May and June month. Now, after writing this CTE, my next step was to calculate the 3 month of moving average using average window function. So let's just do that. Select from I'm just going to consider the above CTE. So monthly sales. So this is my CTE name. And from this CTE, I just want to extract whatever the columns that I want to extract. I'm just going to write this. So month is something that I want to extract. Monthly sales also something I just want to extract. And the third column that I want is 3 months of moving average. So to calculate the 3 months of moving average, I'm going to use the average window function over here. So here I will be using rows between two preceding and current row clause to define the window for calculating the moving average. So let's just write that. So the average on my monthly sales that I just derived from my first CT, this one. So this column. So I have to do average on this over. I'm just going to apply window function. It should be order by month, rows between two preceding and current row. So it should actually calculate the average of two preceding and the current. So 100 plus 350 plus 300. So this is how it's going to calculate for the month of March. That will be 100 plus 350 plus 300 divided by 3. So it will just calculate like that. And it is going to be moving average of sales. That is 3 months of moving average of sales. If I just round the result, then I can just make use of round function. So let's just round off this, and I just want to round it by 2 decimal places. So sorry. Okay. Now at last I just want to perform the order by function. So that is going to be on my month column. So it will make sure that my output is displayed in the chronological order. So if I just run my complete query, what I will be getting is some kind of error on my monthly sales. So okay, so this is my okay. I hope it should give the result now. Yeah. So as you can see that we have got our expected output. So we have successfully calculated the 3 months of moving sales. So here I will just quickly explain
what we have just done now. So we first calculated the monthly sales using a CTE. So this is my CTE name, monthly sales. And to do that, I just made in this CTE, I just applied date format function. So this will just extract the order date in this format, year and the month. And I just applied the sum function on my monthly sales to get the total amount of the sales for that for that particular month and year combination. Now now later on, I just applied a window function to calculate the rolling 3-month moving average, giving us a clearer view of monthly sales trends. So here I just applied this. So window function over order by month, it should be ordered by month, it should not be like in different orders. Definitely we will be applying order by month, rows between two preceding and current row. So here using this, it just calculate the average of current month and the two preceding months. So this clause actually defines the window for calculating the moving average. So that's how you can just calculate the moving average. The question is on calculating the average transaction amount per year for each user. So let's begin. So the question is, imagine that you are an analyst at American Express and you have a database table named transactions, which contains the transaction data of the users. So this is the input table that you have. So transaction ID is nothing but a unique identifier for each transaction. User ID is the ID of the user who made the transaction. Transaction date is the date when the transaction happened, and transaction amount is the amount spent in the transaction made by the user. Now your task is to calculate the average transaction amount per year for each user, specifically for the years 2018 to 2022. So let's take a look at the input table and the output table over here. So here is the table. Now taking a look at the input table, you can see that for the user ID 269 has made the transaction on 15th of August with the transaction amount. Let's say this transaction amount is in dollars, so it has made the transaction as $500. Similarly, keeping the transaction ID second with the user ID 478 has made the transaction on 25th of November with the transaction amount 400, and so on for the upcoming user IDs. Now, since we have been asked to calculate the average transaction amount per year for each user, specifically for the years between 2018 to 2022, so your result should look like this. It should have three columns in the table. One column that denotes the year, then another that denotes the user ID, and the third column that denotes the average transaction amount for that particular user ID in that specific year. Now, if you see for the year 2018, there are two transactions have been made, one with the user ID 269 and another with the user ID 478. So that there are only one transaction. So the average amount for this is going to be the same, that is 500. Similarly, for the user ID 478, the total amount is 400, and therefore the average transaction amount is going to be the same, that is 400. Now taking a look at the year 2019, we can see that there is only one transaction having the transaction ID 3 made by the user 269. So since there is one transaction on the date, which is this one 01/05/2019, and the transaction amount is 1000, so keeping the total amount as 1000, therefore the average amount is also 1000. And similarly for the year 2020, 2021, and 2022. So as we can see here that each row in the output represents the average of transaction amounts for a user in the specific year. So since each user has only one transaction per year in the input table, so the average is equal to the transaction amount for that year. Now let's just take a look at the solution steps and the thinking approach to solve this problem. So our first step would be to understand the problem. Since our goal is to calculate the average transaction amount per user for each user within the range of years between 2018 to 2022. So we need to actually group the data by year and user and then compute the average for each group. So that's how the very first step is, just to understand that what is something that we need to calculate and what is our goal. Now coming to the second step, we can see that we have to convert the transaction date column to the date format, since we don't know whether it's in date format or in the string format. So first of all, we have to make sure that the column is in the date or date time format. Now coming to the third step, it is to extract the year from the transactions date, since we have been asked to focus only on transactions which have been made from the year 2018 to 2022. So that's why we just have to extract those years. And in the fourth step, we have to filter those relevant years using where clause. And the fifth step is, as we already discussed in the step one, we need to group the data by year and user, since we want to ensure that the average is computed separately for each user for each year. That's why we need to group the data by year and user. Now coming to the last step, we just need to calculate the average transaction amount by using the average function on the transaction amount column to calculate the average transaction amount for each user and year group. So that's how we are just going to proceed with the solution. So let's now move on to MySQL Workbench to implement this. Guys, coming to the interface of MySQL Workbench, you can see that this is the transactions table, which is our input table over here. We have been asked to calculate now since the average transaction amount per user for each user, specifically for the years between 2018 to 2022. So since our first step was to convert the transaction date column to date format, so let's first do that. So here I'm just going to begin writing my query over here. So select, and now I just want to convert the transaction date column to date format. So for that, I will be making use of string to date, str to string to date function, which is defined in MySQL. But if you're working in PostgreSQL, then you can just make use of toDate function. So this is for MySQL. So here, transaction date, and your format has to be month first, then slash, then day slash, then year, right? So this is how your format has to be. Now since we want to extract the year, so I'm going to write year on this. So this will actually extract the year. That has to be your first column that needs to be extracted. Now second one is the user ID, and the third one is the average that we are just going to compute after doing everything. So this is from my transactions table. Now where this the year that you just extracted, so this year has to be between 2018 and 2022, and at the last you will just have to apply the group by clause on the year and user ID, since you want to compute the average transaction amount for each user for that specific year. So that's why you want to do that. And now to compute the average, we are just going to make use of the average function on the transaction amount column. Transaction amount column. So this will just compute the average transaction amount. Okay, so that's how it's going to happen. Let's just proofread this. Okay, so this has to be in 1 second, guys. Okay, now again this has to be in comma. Okay, yeah, so let's just run this, and you're able to see that the query generates one row for each user ID for every year from 2018 to 2022, and the output includes year, transaction year, user IDs, which is the client's identifier, and average transaction amount for all the transactions made by the client during that year. So that's how you just got your desired outcome. So I'll quickly help you understand the all the steps that we just did. So in the select clause, what we did over here is we just converted the transaction date column to date format, since this was in the string format initially. So this is how the date format has to be: month, date, and then year. And then we just extracted the function, we just use the year function to extract the year from a date value, since transaction date is stored as a string in the format. So we first converted into a date using string to date function, and then we just extracted the year, since we want to apply condition that our year has to be between 2018 and 2022. Second, we wanted to extract the user ID, since the column represents the client ID used to group the data for calculating averages. And the average function actually calculates the average transaction amount for each group of data defined in the group by clause. So this is the from transactions clause. Now coming to the where clause, we just applied the condition that we want our year to be between 2018 and 2022, and at the last we just applied the group by clause on the year column and the user ID column, since we wanted to make sure that we are calculating the average for each unique combination of year and user ID. The question is about calculating the number of delayed orders for each delivery partner. So as you can see, the question has been asked in this HackerRank assessment by Swiggy. So here's the scenario that you have a table named order details. It contains details of the orders. Each row in this table represents an order including details such as delivery partner, the actual delivery time, and the predicted delivery time. And you have to write a SQL query to calculate the number of delayed orders for each delivery partner. And a delayed order is defined as one where the actual delivery time exceeds the predicted delivery time. So for example, if an order was predicted to be delivered in 60 minutes, but it took 90 minutes instead, then the order would be considered delayed. So let's take a look at some sample data from the order details table. So we have columns like order ID, customer ID, city, date, delivery partner, order time, deliver time, predicted time, and AOV, which represents the average order value. Now to determine whether an order was delayed, we need to calculate the actual time of the delivery, and we will just have to compare it with the predicted time. And if in case the actual time of the delivery comes out to be greater than the predicted time of the delivery, then the order will be considered as the delayed order. So as you can see from the delivery partner column, we can see that there are two partners, partner A and partner E. So let's see for the order 1, which just got placed at the time 10 a.m. and it just got delivered at 11:30 a.m. So we can say that the actual delivery time it took was 90 minutes and the predicted delivery time was 60 minutes. So we can say that this order has been delayed. Now if we see for the order number 3, which was delivered by the partner A again, it just got placed at 2 p.m. and got delivered at 3:45 p.m. So we can say that the actual delivery time between these times is 105 minutes, which is actually greater than the predicted delivery time, which is 60 minutes. So we can say that this order is again delayed. Now if we see for the partner B, with the order ID 2, it just got placed at 12 p.m. It got delivered at 1:15 p.m. So we can say that the actual delivery time is 75 minutes and the predicted delivery time is 45 minutes. So again, this order is again delayed, since actual delivery time is greater than the predicted delivery time. Now if we see for the last order with the order ID 4, it just got placed at 4 p.m. and got delivered at 5:30 p.m. So we can say that the actual delivery time is 90 minutes, and also we can see that the predicted delivery time is also 90 minutes. That means that this order got delivered on time and it is not delayed. Since that we have to find the count of delayed orders for each partner. So if for the partner A the count of delayed orders is 2 and for the partner B the count of delayed order is 1, so our output should look something like this. With the delivery partner A, the order count of delayed order is 2, and for the partner B the order count of delayed order is 1. But now the question is, since we have to find the number of delayed orders for each delivery partner, and to do that we will first have to find out the actual time of the delivery that the partner took to deliver the order. And to do that we will first have to figure out the difference between the delivery time minus order time. And then in that case we will be able to find out the actual time it took to deliver the order, and then we will just compare it with the predicted time. So how will we calculate the actual time of the delivery to deliver the order by the respective partner? So to do that, SQL introduces a function for that, and that function is nothing but timestamp diff function. And this function is crucial for calculating the difference between two date time values, and it can return the difference in various units such as seconds, minutes, hours, etc. So let's just take a look at the syntax of the timestamp diff function. So it accepts three parameters: unit, expression 1, and expression 2. Unit denotes the unit for the result, and it can be any one of the following: either microsecond, second, minute, hours, day, week, month, quarter, year, anything. The expression 1 is nothing but the first date or the date time expression, and the expression 2 is the second date or the date time expression. Now it is important to note that expression 1 and expression 2 should be in date time format, since it calculates the difference between two date time values. But so in our case, if we just apply the timestamp diff function, it should look something like this, since we have to calculate in minutes, and since we have to calculate the difference between the deliver time and the order time. So this is how it will look like. But now, since there is a challenge that the order time and deliver time are stored as time data types. As you can see from the table, the order time and deliver time has been just written in the time data types, which only include the time of the day and not the full date and time. And since we already discussed that our expression 1 and expression 2 must be in the date time format, so to do that, this is the problem that we have, since they are stored in. So to do that, to just solve this problem, we will have to combine the date and order time to get the exact moment the order was placed, and similarly we will have to combine the date and deliver time to get the actual delivery moment. So what we are going to do over here is, for the order time, we will just combine the date and order time so that it will be converted into date time format. So these two columns must be converted into date time format, just to make sure to just find out the actual delivery time of the order. So this is how we are going to solve this question. So let's now move on to the solution steps that we are just going to follow in order to write a SQL query. So the first step would be to find the actual delivery time taken by the delivery partner using timestamp diff function, as we already discussed. And our second step would be to compare the actual delivery time with the predicted delivery time to find the detailed or delayed orders. And our order will be delayed order if in case the actual delivery time that we will be just finding it from the step 1 using timestamp diff function, if it comes out to be greater than the predicted delivery time, then it will be considered as the delayed order. And our last step will be to use the group by clause to aggregate the results by delivery partner, since we have to just calculate the results for each delivery partner, and then we will just use the count star function to calculate just count the number of delayed orders for each delivery partner. So let's now move on to the implementation. So guys, as you can see, I have imported my order details table, and you can see the columns has been displayed over here. And since I want to count the number of delayed orders for each delivery partner, so I'm just writing my query. So I want my delivery partner column to be there in my displayed, and later on I'm just writing it from order details table. Yes, now to find the count of delayed orders, since we already discussed that we have to compare the actual time it took to deliver the order with the predicted time. So let's first find out the actual time to just deliver the order. So where our actual time will be calculated using timestamp diff function. So if I just do timestamp diff, and in the bracket I'm just writing minute, which is my unit, and my expression one is order time, and my expression 2 is deliver time. Okay, so now here is, since it is in time format, we will have to convert it into date time format. So to do that, we will just make use of concat. So I will just do concat of date comma, just give some space, and then here it will be order time. So this is how I'm just going to convert my expression 1 into date time format. Similarly, I'll convert the order time again into date time format. So I'll use the same function, which is the concat function, and then I'll just write date and then space comma deliver time, sorry, comma deliver time. So yes, so it gives me so now I can see that it has just combined the order time into date time format, and it has combined the deliver time into date time format. And since this complete should be greater than my predicted time, so this function will calculate the actual delivery time uh, taken by the delivery partner to just deliver the order. So next we wanted to group by, since our last step was to just group by on delivery partner column. So I'm just doing that. And also we had to apply the aggregation function, okay, which is our count star function. So just using count star. So this will actually calculate my order count star as order count. So my where condition will already filter the rows, which are the rows of the delayed orders. And since I have already filtered my delayed order rows, I just have to count them. So I can just directly count it like that. Okay, so I have to close this. Yes. So if I just run this query, let's just run the query and see the results. So we can see that we have got our output with the delivery partner and the respective count of delayed orders. So let's just break down the solution. I'll just quickly explain over here everything. So we have used the concat date and order time this here to just combine the date and order time into a single date time value that will represent the when the order was placed. And similarly we have done the same for the deliver time to just combine the date and deliver time into a single date time value, since this is only the syntax of timestamp diff function, that the expression 1 and the expression 2 must be in date time format. So we have just converted it using the concat function, and using the where clause we have just filtered out only those orders where the actual delivery time exceeds the predicted delivery time, just in case to just filter out the delayed orders. And finally we just group by the delivery partner to count the number of delayed orders for each delivery partner, and we just use the count star as count order count to just aggregate it and calculate the count of the delayed orders. So let's understand the question here. So assume that you are given a table named employee with the following schema. You're given ID, which is nothing but the primary key. Name is the employee name. Department is nothing but the department the employee works in. And manager ID is the ID of the employee's manager. If in case the manager ID is null, the employee has no manager assigned to him. Now your task is to write a SQL query to find the names of managers who directly manage at least 5 employees in the same department. And you have to return the department name and the total number of direct reports for each manager in your output. It is also important to note that only employees from departments with more than 10 total employees are considered in your query. So let's go through the problem breakdown here. So the things that you have to keep in mind is, first, you need to find managers who have at least 5 direct reports. Second thing, the employees they manage must belong to the same department as the manager. Third thing, you only need to consider departments with more than 10 employees. And last thing is, your output should return the manager's name, their department, and the number of direct reports. So based on the question, let's take a look at the structure of the input table and the output table. So here is how your input table looks like, and here is how your output table looks like. So your input table lists employees with their respective departments and the manager ID. And your output table shows the managers who have at least 5 direct reports within the same department along with their department and the count of direct reports. So in this example, if you see, the employee John manages 6 employees in the HR department, if you can see in the input table. So there are more than 1 2 3 4 5 6. So there are six employees that John is the manager of these 6 employees here. So that means that this employee actually satisfies the condition of having at least 5 direct reports in the same department, since as we can see that all of them belongs to the HR department here. So our output contains only this employee name John having 6 direct reports, which is nothing but the number of direct reports, and the department name. So now I hope you understood the input table and the output table here. So let's now move on to understand how to approach this question and what would be our solution steps to solve this problem. So let's move on to the solution steps here. So our first step would be to perform the self join to identify direct reports. Now since the employee table contains both employees and their manager relationships, so we will need to join the table to itself to match employees with their managers. So what this will do is, it will just help us count how many employees directly report to each manager, and that's why we will be performing self join. In the second step, we will just filter by department, since we need to ensure that the direct reports and their managers belong to the same department. So this can be achieved by adding condition to the self join, ensuring that both the employee and the manager are from the same department. Now in the third step, we have to count the direct reports. So once we identify the managers and their direct reports, we will just group the result by the manager ID and department and count how many employees report to each manager. So we will then filter out managers who have fewer than 5 direct reports. Now in the fourth step, we are just going to consider departments with more than 10 employees. Since we had to ensure that we are only looking at departments that have more than 10 employees, so we will create a subquery that counts the total number of employees in each department. So and then we can just we can only include managers who belong to departments where the total employee count is greater than 10. So in this case, we are just going to solve this problem. We are just going to apply these steps to write a SQL query. So let's now move on to the implementation. Here we will just write a SQL query in MySQL workbench. So guys, here we are just going to apply the steps that we just discussed. So in this case, our first step was to perform self join. So let's just do that. So in the first step, we are just going to write a SQL query with a select statement, and whatever the columns that I want to retrieve, I'll just write it afterwards. So this is my employee table. So I'm just giving the alias as M for now, and I'm just going to join this table by itself, since it is going to be self join. So I have given the alias M just to make sure that here we are referring to the managers, and here we are just referring to employees. And in this case,
we need to identify the relationship between a manager and their direct reports. So here I will just apply my condition on m dot id should be equal to e dot manager id. Also, I have one more condition that the departments of these should be same. So m dot department should be equal to e dot department. Since that the employee and the manager belong to the same department, and that's why we have just applied this condition. And one question that you might think of, that why did we do self join here? This is because both managers and employees are stored in the same table, and since there is no direct condition without performing a self join, so what self join will help us do is to associate employees with their managers while staying within the same department. So here we have just performed the self join, and now I'm just going to pre-filter departments with more than 10 employees. So to do that, I'm just going to write another query, so that will be my subquery. So in this case, I will just retrieve my department and another column, which is nothing but the count, so that I'll just apply here. So this is my employee table, and here in this case I will just do the group by on department, and having count of id should be greater than 10. So this was one of the condition. Before we count how many direct reports each manager has, we need to ensure that only departments with more than 10 employees are considered, and this is a kind of filtering condition, and we just handled it using a subquery. So whatever the column that I want to retrieve, I'll just write it here. So count of id, it will just give me total employees. Okay, so if I just run this query, this small query, what I'll be getting is, I got that the HR department has 10 employees over here. So this is the only department that actually satisfies our condition. And if I just remove this filtering condition, I'll just get the count of employees for each department. So as you can see that the department finance has 4 employees, which does not actually satisfies our condition, because we only want to consider those departments that have more than 10 employees. So in this case, I will just apply my same condition, that having count of id should be greater than 10. So if I just run this, I'll see this. So here we just join back this subquery to our main query here. So join this subquery. I'm just joining this subquery, main query, based on the condition that my department should be same. So I'll just give some alias to this subquery. So let's just give an alias d, let's say d, on m dot department should be equal to d dot department. Now we just have to perform some grouping. So now we will just apply our group by condition on id, name and department. Why we are doing this? So this is because grouping is necessary, because we want to calculate an aggregate value, which is nothing but the number of direct reports for each manager, and without grouping we would not be able to use count function to determine how many employees report to each manager. So that's why we are just applying the group by condition over here. Now our last condition was having count of e dot id
should be greater than or equal to 5. Okay, either 5 or more than 5. It's fine to use any of them. And whatever the columns that we want to retrieve, I will just write it over here. So I just want m dot name, name of the employee. Then so this will be my manager name, since I wanted to output the manager name in my query. Second, I wanted to report the department name, so this will be the department. And third was the count of e dot id as direct reports. Now let's just do a quick check to this query. So here we have not specified the names of the tables that it should refer to. So it should refer to the manager's employee table. So if I just run this query, complete query, what I will be getting is, I've got my answer, say manager name John with the department HR having 6 direct reports. So this was my expected output. So in this case, what we did over here is, so I'll just quickly explain you again the step-by-step procedure. So our query had multiple objectives. Say we had to find managers and their direct reports, first of all. And second, we wanted to filter departments based on total employee count. Third, we wanted to group data by manager and department to compute the number of direct reports. So the 3 columns that we wanted in our output: manager name, department, and the direct reports. Now to do that, we actually performed self-join for manager-employee relationship. Since the managers and employees are in the same table, so we need to identify the relationship between a manager and the direct reports. So in this case, what we did here is we just gave the alias to both. So here, to associate employees with their manager, we just did self join, and the left side of the join alias M represents managers, and the right side of the join alias E represents employees. And we just applied our join condition on the m dot id should be equal to e dot manager id, and the department should be same. So since we are finding employees whose manager id matches the manager's id, so that's why we just applied this condition. And for the same department, the employee and the manager belong to the same department, that's why we just applied this condition. Next, we wanted to filter the departments with more than 10 employees, because this was also one of our filtering condition. And to do that, I just wrote a subquery. So here we just count how many direct reports each manager has. So in this query, we just count how many direct reports each manager has. And to do that, we just applied the group by on the department, and having the condition that my count of id should be greater than 10, since this was our condition. And then after just writing this subquery, we just joined it with the main query on the department, again on the department, since the department has to be the same. So we have here applied all the filtering conditions, and now we just wanted to compute the number of direct reports. And to do that, I just applied the grouping, since we wanted to calculate an aggregate value, which is nothing but the number of direct reports for each manager. And we just did the group by clause on this, and just applied the condition that our count of id should be greater than or equal to 5, because since we only want to filter out the names of those managers who has more than 5 direct reports. So this is how we just wrote our query. So the question involves working with a table named job listings, which contains job postings from various companies on LinkedIn. And you have to write a SQL query that identifies and counts the number of companies that have posted duplicate job listings. Now, duplicate job listings are those job postings that are from the same company having identical title in description. So let's now take a look at the input table and the output table. If we see for the input table, it has 4 columns: job ID, company ID, title, and description. And now since we have to find out duplicate job postings that are those job postings from the same company having identical title and descriptions. So in this table, if we see for the company with the company ID 345, which belongs in the row number 3 and 4 here, 3 and 4, which has two job listings, that is 945 in 164 with the same title, data analyst, and same description. So that means that these job listings are duplicates, and the query should return the number of unique company IDs that have posted at least one pair of duplicate job postings. So based on this data provided, based on this input table, our output should look like this, with the count of duplicate companies as 1, which is 345. Let's now understand how to approach this question, what steps to follow in order to write a SQL query to find out the duplicate companies. So you can even pause the video here and think through the solution approach, that what steps you are going to follow to write the SQL query. So let's now move on to the steps. So the first step is to identify companies with duplicate job listings. And to do this, we will just use the count function to calculate the number of job ID entries grouped by company ID, title, and description. And in the step 2, we will just filter for companies with duplicate job listings. So we can just proceed to filter the previous query by converting it into a common table expression and selecting only the rows where the job count is greater than 1 to indicate the presence of duplicate job listings. Also, to obtain a count of unique companies, we will apply the distinct keyword on the company ID column. So that's how we are going to approach the question. So let's now move on to MySQL Workbench for the complete implementation. So guys, as you can see, I have my input table already imported here with the columns company ID, job ID, title, and description. And now I'll write a SQL query to find the unique the count of unique companies with the duplicate job listings. And to do that, our first step was to identify companies with duplicate job listings. And by duplicate, we mean listings from the same company that share identical titles and descriptions. And to do that, we will just make use of the count function, and we will just group our entries by company ID, title, and description. So let's just write the query. So select from job listings. This is my table name, and I'll just apply the group by clause on the company ID, title, and description. And the columns that I want to retrieve, I'll just write over here the company ID. Next, I want title, I want to see description, and also I just want to see the count of job ID. Count of job ID as job count. So if I just run this query, I'll see that this query gives us a table that shows the count of job listings grouped by company, title, job title, and job description. Now, what we are going to do is, our second step was to filter for companies with duplicate listings. So now that we have identified where duplicates might exist, the next step is to filter this data to focus only on companies that have posted duplicate listings. And to do this, we will just convert this query, whatever the query we have just written, into a common table expression, and then we will just filter the results to show only those where the job count is greater than 1, and those will be the only duplicate companies. So here we can see the job count is greater than 1 only for the company ID 345. So we'll just count this, and then we can just find out the output. So I'm just converting it into my CTE. So just writing the CTE name as job counts CTE as, and this is my CTE. And from this CTE, I just want to count the distinct company ID. Since I wanted to count the distinct companies having duplicate job listings. So I'm just giving the alias as duplicate companies. This I'm going to take it from my CTE, which is the CTE name was job counts CTE. And here I'm going to apply a condition that where job count should be greater than 1. So this is my final query. And if I just run this query, what I'll get is I've got my output saying the duplicate the count of duplicate companies having the count of companies with duplicate job listings are 1 here. So this was our expected output, and it matches with the results. Also, there is one more method that I want to talk about. Since the first method was with the help of CTE, and the second method was, let's just write the method 2 with the help of subquery. We can also write with the help of using subquery. So let's just implement that as well. So in this question, I'm going to so in this method also, I'm going to use the same steps that we actually performed in the method 1. So here I will just find the select from my job listings table. Okay, and since I'm just doing the step 1, that is identifying the duplicate job listings, and I'm following the same approach. I'm just grouping the company ID column, the title column, and the description column. And the columns that I want to retrieve is again the same, the company ID, same the title, and another one was description. And later on, I just wanted to count the job IDs. So job ID as job count. And from this, so I'm just going to make this as a complete subquery. So from this, from this subquery, I want to retrieve the count of distinct company ID as duplicate companies, which I just did in my first step. Okay, I just have to close this. Okay, and here I'm just going to apply the condition that my job count should be greater than 1. So the same methods I use, same approach I use, same steps I followed. I just in the above method I just wrote a CTE, and in this method I just made this as a subquery. So if I just run this table, I'll get the same results, and if I just run this query, I'll get the same results. See, and if I just run the complete query, I'll get my output. It's showing some errors saying that every derived table must have its own alias. Okay, so we just forgot to give it its alias. So let's just give this as alias as job count CT. So if I just run this again, I should get the output. See, duplicate companies as 1. So that's how we can just count the number of companies with duplicate job listings.
So the question is on finding the possible cricket match combinations. So let's understand the question over here. So the problem statement over here is that you are given a table named teams with a single column team name that contains the following rows. So here is your input table, and these are the rows that you have been given: CSK, KKR, GT, DC and LSD. Okay, so these are the cricket teams. Now you have to write a SQL query to generate all the possible unique match combinations between the teams in the format team 1 versus team 2. So basically you have to generate all the possible unique match combinations between the teams. That should be in the format team 1 versus team 2. So basically your output should be like CSK versus KKR, CSK versus GT, CSK versus DC, like that. Okay, but there are some constraints that you have to keep in mind. So the first constraint over here is that each pair should appear only once. For example, CSK versus KKR is valid, but KKR versus CSK should not appear again because it will be counted as duplicate. And since we have to find only the unique match combinations, then definitely that will be counted as a duplicate. And the second constraint over here is that a team should not be matched with itself. For example, CSK versus CSK is invalid. So basically we have to generate possible unique match combinations, and definitely a team cannot play against itself. So therefore CSK versus CSK, like these combinations, would be invalid. So I hope the question is clear. Now you have been given 5 cricket teams over here, and you have to generate the possible unique matches in the format team 1 versus team 2. So that would be your expected output. So let's now move on to understand how to solve this problem. What would be your problem solving approach? So guys, you can even pause the video here. You can think through the solution, what could be the ideal approach to solve this problem, and then here we are going to understand how to approach the problem. So the first step would be to understand the problem. So basically it is very important for you to understand the problem first. Since you have been given a list of team names in a table and you need to generate all the possible unique matchups between two different teams, the output should be in the format team 1 versus team 2. And definitely duplicate or reverse matches should be avoided. A team should not play against itself. So these are the conditions that you have been given, and this is your requirement. Now the second step would be for you to find out the expected output. So basically we are only given the input table over here. We are not given the output table. So here in this case you have to present your output table. So here you have to make use of the permutations and combinations, and what could be the possible combinations that we can have from these cricket teams. So using that you have to find the expected output. Now your third step would be to perform the self join to create all the pairings. So basically here we are given single one table, and to definitely create the pairings we will be making use of the self join concept to join the teams table with itself. That will help you create all the possible pairings. And later on you have to simply apply a condition. Your fourth step would be to simply filter out duplicates and self matches. So that would be your fourth step, to filter out after creating all the pairings. This step would be to filter out the duplicates and the self matches, because that is something needs to be avoided. Okay, and at last you just need to format your output, making sure that you are writing your output in the format that has been given, team 1 versus team 2. So to do that you can definitely make use of the concat function in MySQL to format the match string. So that's how you are going to approach this problem. So these are the steps we are going to follow while solving this problem. Okay, so before moving on to solving the problem, let's first find out the expected output before proceeding with the solution. So what we are looking for here is, we are looking for all the unique matchups between 5 teams that we have been given, where order does not matter and a team does not play against itself. And since it is very clear that it is a classic case of combinations and not the permutations. So the formula for combination is like, if we have to select r possible items from total n number of items, the formula for the combination is NCR, which is given by n factorial divided by r factorial into n minus r factorial, where n is the total number of items and r is the number of items chosen. Okay, so the possible combinations of choosing r items from n items is given by NCR, and the NCR is definitely denoted by this formula. So guys, in this case, we have to choose 2 items from a group of 5 items. So here, when choosing 2 items from a group of n without repetition and without order, the number of combinations is going to be, we can simply substitute r is equals to 2 in the formula, where n is equals to 5. So after substituting n is equals to 5 and r is equals to 2 into the formula, we are going to get 10 possible unique pairings. Okay, so let's now calculate what would be these 10 unique pairings. So since we are going to perform self join, let's just match each record of the left table to the each record of the right table. So let's just take the case of the CSK. So CSK versus CSK, that is going to be invalid. Next, CSK versus KKR, then CSK versus KKR, CSK versus GT. Then comes CSK versus GT, CSK versus DC, CSK versus LSG. So there could be 4 possible combinations that come from CSK. Now let's talk about KKR. So KKR versus CSK will be invalid because we have already taken CSK versus KKR. Then KKR versus KKR again invalid. Now KKR versus GT, KKR versus DC, and KKR versus LSD. So there will be 3 possible combinations from KKR. Now let's take for GT. So for GT, again GT versus CSK will be invalid because we have already taken CSK versus GT before. Now GT versus KKR again invalid because we have taken KKR versus GT before. Now GT versus GT again invalid. So there will be only 2 possible combinations from GT, that is GT versus DC and GT versus LSG. Now let's take for DC. So again DC versus CSK would be invalid because we have already considered CSK versus DC. Then DC versus KKR will again be invalid because we have already taken KKR versus DC. Now DC versus GT again will be invalid because we have already considered GT versus DC. Now DC, so there would be only one possible combination, that is DC versus LSG. And if we talk about LSG, all the possible combinations would be invalid because we have already considered CSK versus LSG, then KKR versus LSG, then GT versus LSG, then DC versus LSG, and LSG versus LSG will be invalid. So there will be 4 plus 3 plus 2 plus 1, that is in total 10 combinations would come out. 10 unique combinations would be there. So your final expected output would be this. So I hope you understood how we calculated the expected output. Now there is one thing I would like you to note, that is, if order did not matter, for example, if we were allowed to count CSK versus KKR and KKR versus CSK both, in that case, we would not have used combinations. Instead, we would have used permutations. So I hope you are clear with the question now. Let's now move on to write the SQL query in MySQL Workbench. So guys, this is the interface of my SQL Workbench, and as you can see, I've already imported my input table, that is my teams table, and these are the records that I had. Now, since I want to generate all the unique possible match combinations, so to do that, I am going to follow the steps that I just discussed. And first of all, I'll be doing self join on both. So I'm just writing my query, select from, this is my teams, and I'm giving one table as T1, then it will be join, then teams T2. Now, since there are 2 conditions that we have, one is that we have to avoid the self matches, and second one is that we cannot include two same combinations. For example, if CSK versus KKR exists, then we cannot include KKR versus CSK, and we cannot include the self matches, like CSK versus CSK cannot come, KKR versus KKR cannot come, like that. Okay. So to do that, basically we are actually going to make use of a condition on which I will be making this self join. So the condition would be here is, I will be doing it on T1 dot team name should be less than T2 dot team.
Now, why I have used this condition is it will definitely meet my both the criteria. That is, it will first avoid the self matches. Uh, it will definitely not include CSK versus CSK in my output, because both the names are not the same. Okay, definitely they are different. That's why it is not going to include the self matches. Secondly, it will only keep one direction, because the less than operator over here compares the strings alphabetically. So if CSK less than KKR is true, then definitely KKR versus KKR less than CSK would be false. Okay, so only one of the two reverse pairs will pass this filter. And now we just have to format our output in team 1 versus team 2 format. So for that, I'm just making use of the concat function over here. So concat, here I'm just going to write my t1 dot team name comma versus, and then t2 dot team name. So this query is going to give me my final answer. That is, 1 second guys. Okay, so as you can see over here, so I will just give as matches. Okay, so these are my possible combinations that I have got here. So this is my output. As you can see here, 1 2 3 4 5 6 7 8 9 10. So this is my expected output that I have got, the 10 possible combinations. And if I do order by matches, then it will give me my complete output. It has ordered it by matches.
So in this question, we have to extract the top 2 highest selling products within each category. So let's understand the question first. So imagine that you are given data about Amazon customers, the products they purchased and their spending. So you are given this table. The table name is product spend, and it contains 4 columns: the category of the product, name of the product, the user ID is nothing but the ID of the user, and spend is nothing but the amount that the user has spent it to purchase that specific product. Now you have been asked to find the top 2 products with the highest total spend within each category. So let's understand the input table and the output table here. So here, this is your input table, and since you have been asked to find the top 2 products with the highest total spend within each category, so your output would look like this. It will contain 3 columns: category, product, and the total spend. So now to do that, you will have to find the total spend of each product in each category, right? So for the appliance category, if you clearly see here, we have different categories of the products: the appliance, electronics, fashion, groceries, and home. So if you see for the appliance category, you can see there are 2 distinct products. One is the refrigerator and then the other one is the washing machine. So let's first calculate the total amount spent for the refrigerator product. So the total amount spent is nothing but 26 plus 9. Sorry, 26 plus 3. So this will come out to be 29. The total spent for the appliance and for the appliance category with the product refrigerator, it is 29. And for the second product, washing machine, it is 19.8. And now since we have been asked to find the top 2 products with the highest total spend within each category, so these two are the top 2 products here. But if we see for the electronics category, in the electronics category, we can see that there are 3 distinct products. The first one is the vacuum, second one is the wireless headset, and the third one is the laptop. And if we find the total spend for each product, so for the vacuum, it will come out to be 5 plus 15, which is nothing but 20. For the wireless headset, it is 7. And for the laptop, it is 999.99. So the top 2 will be 999.99 and vacuum. The top 2 will be the laptop and the vacuum. The laptop had the total spend 999.99, and the vacuum, the product vacuum, in the electronics category had the total spend 20. So this is how we are calculating our top 2 products with the highest total spend in each category. So now the thing is, I hope the output is clear, but now the thing is, how will we approach this question? How will we write our query? And what methods we will be using to solve this question, to find the output from this input table? So you can even think through here. You can just pause the video and just think that what steps we will be applying, what methods we will be using to find this output. So the first method that we will be using is, we will just calculate the total spend per product and category. So in order to do that, we will group the data by category in product to find the total spend for each combination. And the second step that we will be performing is, we will rank the products within each category. And to do that, we will use the rank window function to assign a rank to each product based on its total spend within its category, right? And the third and the last step will be, we will just filter the top 2 products within each category. So to do that, we will just select only the rows with the rank of 1 and 2 to get the top 2 products in each category. So this is how your our solution approach will be. So let's understand. Let's write a query in MySQL workbench. So guys, here I have already imported my product spend table. It has 4 columns: category, product, user ID, and spend. And since we want to calculate the top 2 products with the highest total spend within each category, and to do that, our first step will be to calculate the total spend per product and category. So let's do that. So select from my product spend table, product spend. The columns that I want to retrieve is the category column, the product column, and the total spend column. So to calculate the total spend, we will just have to first group the data by category in product to find the total spend for each combination. So here we are just applying the group by clause. Why we are applying the group by clause is, since we want to calculate the total spend for each unique combination of category and product, and to do that we will have to group the data by category and product, and further we can apply the sum function, which is nothing but the aggregation function, to calculate the total spend. So here I am just grouping the data by category and product. Category, product. Now for each category and for each combination of category and product, I want my sum of spend. Sum of spend, which is nothing but the total spend. Total spend. Okay. So if I just run this, I have got my for the appliance, the for the appliance category, and for the product refrigerator, the total spend is 29. For the washing machine, it is 19.8. For the electronics, as we can see, there are 3 products: vacuum, wireless headset, and the laptop. And the highest product spend is of the laptop, and the second highest is of vacuum. Similarly, for the fashion, we can see that there is only 1 product, so this will come in our output. For the groceries, only 2 products. For the home, only 2 products. So this will be coming in our output. So now our second step was to rank the products within each category. So just rank the products on the total spend column. With the product with the highest total spend will get the rank 1, and the product with the second highest will get the rank 2, and so on. So let's just apply the rank function in this. So the rank over, now since I want to find for each category, so I'll do the partition by on my category column, and then I will be doing my order by on the total spend column, but we cannot directly write the total spend column here. So we will just write our sum of spend. And this should be in descending order. Why in the descending order? Because uh, because the rank the product with the highest total spend will get the rank 1, and the next highest will get rank 2, and so on it will be uh, going on. So we want to extract the first two, so therefore I am just doing the descending order, and I'll just close my parenthesis here, and I'll just name this new column as ranking. Okay, and I just have to apply comma here. So let's run this query. What it gives us, it has given us the rankings. So if we see for the electronics category, it has given rank 1 to the laptop, the rank 2 to the vacuum, and rank 3 to the wireless headset. And thus we want to find the top 2 highest products. Top 2 highest products within each category. So we will be having uh, all the columns except this third ranking column in our output. So to do that, we will just make use of a common table expression, which is nothing but a CTE. You can also do it with the help of subquery. So we will be doing it with both the methods. So I will just write the method 1. Sorry, yeah, method 1, which is using CTE. Okay, so I'll just make it as my CTE. Okay, so from this with just giving the name of the CTE, ranked spendings as, so this is my CTE, and from this CTE I just want to extract the columns. What columns that you want to extract? The category column I want to extract, the product column I want to extract, and the total spend column that I want to extract. So these 3 columns I want to extract from my CTE, which is nothing but ranked spendings. I'm just writing it from ranked spendings, where, so I'll just apply the condition that my ranking should be less than or equal to 2. So the ranking can be 1 and 2 and not more than that. So it will automatically eliminate the product with the ranking 3. And at last we can also do the order by on category in product if you want. If you don't want, you can even skip this category, sorry, ranking. Okay, so let's just run this query, complete query, and we can see that we have got all these products except the one which was wireless headset in the electronics category, which got the rank 3. So if you want only the top products, you can just keep the where ranking is equal to 1. So you will only get the top products within each category. So this is how you can do. One more method that I told you was using subquery. So let's just do that using subquery. So in this case, okay, so in this case, since we wrote this query, I'll just copy it from here to find the total spend, to find the, okay, it is giving me the total spend in the ranking. So since I want to find the top 2 products, so I'll just make it as separate, as a separate kind of temporary table. So from this table, so I'm considering from this table I want to extract my records. So I just want to extract, so this is my subquery. So what records I want to extract it, I'll just write the name of those records. Just a second, guys. 1 second. Let me just put my upper query. Okay. So the second record that I want is the product, and the third one is that I want is the total spent. I don't want ranking to be there in my output. So this is what I want. Sorry. And I can simply apply my where condition that where x dot ranking should be less than equal to 2. So this is the method of writing using subquery. So if I just run this, if I just run this, I've got the same output. I've got the products with the ranking 1 in 2, and since if you wanted for the ranking 1, you could have just written where x dot ranking is equals to 1. So guys, I hope you have got the solution, you understood the solution, and there we have it. Our final result shows the category, the product, and the total spent for the top 2 highest grossing or the highest selling products in each category. So I hope this video is helpful to you guys, and if you have any other method, please let me know in the comment section. So the question is on finding the net present value for queries from two tables using SQL. So let's understand the question first. Assume that we have two tables, one called NPV table and the other called queries table. The NPV table contains data for different ID and year combination along with their corresponding NPV values. The queries table lists all the ID and year combinations that we are interested in. And our task is to find the NPV of each query from the queries table, and we have to return the output by order by ID and year in the ascending order. It is also important to note that if no NPV is available for a particular combination in the NPV table, you have to assign a 0 value for that. So this is how your sample output looks like. We have 3 columns, ID, year, and NPV, as we wanted to find the NPV of each query from the queries table. So let's see how this output has derived. So if we see that for the combinations of ID 1 and 2019, we can see that the NPV value is 113. So we have listed the NPV value over here. For this combination of ID 2 and year 2008, the NPV value is 121, and this is how it is displayed. For the combination of ID 3 and year 2009, we can see that the NPV value is 12, and this is how it has been derived. And now if we see for the combination of 7 2018, we can see that there is no NPV value present for this particular combination, and since we have been given that if no NPV is available for a particular combination in the NPV table, we have to assign a 0 value for this particular instance. So in the output table, we have assigned NPV 0 for this. Now if we see for the combination of 7 2019, we can say that already the NPV value is given, that is 0, so we have listed the same. Now for the year 7 2020, the NPV value is 30, and similarly for 13 2019, the NPV value is 40. So this is how our output is going to derive. Now let's go through the solution steps to see that how to write a SQL query to find this expected output from these two input tables. So our solution steps are going to be, for the very first step, we are just going to perform a left join on both the tables. This is because we want to include all the rows from the queries table even if there is no matching NPV data. So that's why we are just going to perform left join from the queries table to the NPV table. And we will do it on the matching column, say ID and year on both the columns. Now in a step 2, we are going to handle null values using if null function. So the next step would be to handle cases where an NPV value does not exist for a particular ID and year, and we will be using if null function to replace null values with 0. Now the third step would be to just sort by year, ID and year, because since we want we want to sort our data in the ascending order for the ID and year. So that's how we are just going to solve this question. So let's now move on to the implementation. So guys, as you can see, I have already imported my both the tables, NPV table and the queries table here. So if I just run this query, you can see that all the records of my NPV table has been displayed over here. And if I just run this queries table, you can see that all the records from my queries table have been displayed over here. Now, since I just want to find the NPV for each query from the queries table, so my first step was to perform a left join using perform a left join on both the tables. So let's just do that. So I'm just writing that I just want all the records from both the tables. So from my queries table, since I want each and since I want all the records from my queries table, so left join on my NPV table. So let's just name the queries table as, I'm just giving it as alias Q, and I'm just giving it as alias N, and I have to do it on both the conditions. Say my ID of NPV table should be equal to the ID of my queries table, and also the year of my NPV table should be equal to the year of my queries table. So I'll just do that. N dot ID is equals to Q dot ID, and Q dot year should be equal to N dot year. So if I just run this query, just see what I'll be getting is. So as you can see that I have got all the records. But now what actually we want in my output table is that I just want to query the NPV values for each query from the queries table. So I want to retrieve three columns over here: ID, year, ID and year from the queries table, and the NPV value from my NPV table. So I want all the records from my queries table. So I'm just writing Q dot star, and I want to retrieve the NPV table, N dot NPV. So if I just run this query now, as you can see that I have got my ID and year columns from my queries table and the NPV column from my NPV table. Now since we were given that if no NPV is available for a particular combination for a particular combination of ID and year in the NPV in the queries table, in the NPV table, if you don't see any NPV value for this any combination, say for here 7 and 2018, it is given that null, so we have to replace it using 0. So our second step would be to handle null values using if null operator. So now how will we do that? So here if I just apply the if null, so if it is if null, it should give me 0. Okay, so it should be, the alias should be NPV, net present value. So what this will do is it will just check if whether the NPV value is null, and if it is null, it will just assign a value of 0. Otherwise it will just keep the original NPV value as it is. So this is how we are just going to use this. So if I just run the entire query, you can see that my null value has been replaced with 0. Now at the last, we just wanted to sort the results using order by clause. So order by ID and year should be in my ascending order. So now if I just run this query, you can see that I have got my expected output. So this was my expected output, and you can see that we have successfully retrieved the NPV values from the queries table. So guys, there is one more method to solve this question, that is using case statement. So in this case, we will first create a derived table so that derived table will actually act as a subquery, which will just join the queries table and the NPVs table using left join that we already did. So I will just write that first. So I'll just perform the left join on the queries table, giving the queries table as Q, and I'll just do the left join on my NPV table and I'll just alias it as N. And since I'll be doing it on both the conditions, say ID of NPV table should be equal to the ID of my queries table. Also, the year of my NPV table should be equal to the year of my queries table. So I will just apply both the conditions. Q dot ID and Q dot year should be equal to N dot year. And since I just want to retrieve the NPV values of all the queries from my queries table, so since I want all the columns from my queries table, that is the ID and year columns, and only the NPV N dot NPV as my NPV1, let's say. Okay, so if I just run this, as you can see that I have got my results over here. So now my second step would be that after building my derived table, I'll just use the case statement to check whether the NPV value is null, and if it is null, I'll just assign it the value 0, and if it is not null, I will just keep it the original NPV1 value. So I will just make it as my subquery. Just make it my subqueries. Sorry, from this derived table, I will just retrieve. So select from. So from this table, I will just retrieve whatever the columns I want to retrieve. So I'll just give it as alias as window table, because any subquery, any table should have some alias. So I have just given the alias. So here let's just write the case when statement. Say case when my NPV1 is not null. In that case, it should display my NPV1 value, NPV1. Otherwise, it should just display else 0. It should just display 0, and I will just give it a alias as NPV, because that is something that should be in my output. And also the two other columns that I want to retrieve is the ID and year from my queries table. So from my queries table, so I just write it as Q dot ID as ID1 and Q dot year as year 1. So this is from my queries table, and this is what I just want to retrieve. So that is my ID 1 as ID and year 1 as year. So these are the two columns, ID and year, that I want to retrieve, and NPV I want to retrieve. At the last, I just wanted to do order by on my ID column and the year column. So this is how I'm going to write my query. So if I just run this entire query, you can see that I have got my expected output, which is actually the same as my sample output. So that's all for this solution, guys. So here we have done it using two methods. First method was using if null, and the second method was using case when statement. So both the approaches are valid, but using a case statement provides more flexibility for handling complex conditions, as you can easily add more conditions within the case block if needed. So that's all about the solution of this problem, guys.
So the problem involves calculating the average monthly revenue for each sector using financial transaction data. So let's break down the problem statement over here. So we have two tables. The first one is the transactions table that contains records for various financial transactions made by different companies. So this table has columns, say transaction ID, which is a unique identifier for each transaction, company ID, which is again an identifier linking the transaction for a specific company. Transaction date is the date when the transaction occurred, and revenue is nothing but the revenue generated by the company in that particular transaction. Now the second table is the sectors table. So the sectors table maps each company to its respective sector. So it has two columns, company ID and sector. So company ID is the unique identifier for each company, which corresponds to the company ID in the transactions table. And the sector is the sector to which the company belongs. Now your goal is to write a SQL query that calculates the average monthly revenue for each sector in the year 2020, and your output should show the average revenue for each sector for every month, allowing the company to see how each sector performed financially month by month. So your output should have columns like month, sector, and the average revenue for that particular month and sector. So let's take a look at the input table and the output table over here. So these two tables are your input tables, the transactions table and the sectors table. And this is your output table, which have columns like month, sector, and the average revenue for that particular month and sector combination. So let's see how this output has come up from these input tables. So if you see for the transaction date, we can see that there are 2 months, the January month, January 2020 and February 2020. So let's calculate the average revenue for the January month for the technology sector. So if you see for the company ID 1 here, so the company ID actually belongs to the technology sector. So there are only two transactions made in the January month. So January 2020 with the company ID 1 and company ID 2. So for the company ID 1 has a revenue of 5,000 in January, and since there is only one transaction for the sector in January, so the average revenue for the technology sector is 5,000, as you can see in the output. So the month one denotes that it from the January month with the sector technology, and the average revenue is 5,000. Now, if you see for the company ID 2, so the company ID 2 belongs to the healthcare sector. So if for the healthcare sector, here the company 2 has a revenue of 8,500 in January. So similarly, with just only one transaction for healthcare, so the average revenue has come up to be 8,500 here, since we are only referring to the January month. Now, if you see for the February month, so these are the three transactions that belongs to the February month. So if you see for the technology sector, so this for the company ID 1 has a revenue of 4,500 and the company ID 3 has a revenue of 9,900, and both the company ID 1 and 3 belongs to the technology sector. So to find the average revenue for the technology sector, we just sum up these two revenues, which is the 4,500 and 9,900. So the total will come out to be around 1,400, and then we'll just divide it by 2 to calculate the average revenue. So the average revenue will come out to be 7,450. So as you can see, for the February month with the technology sector, our average revenue has come out to be 7,450. Now the last one is the only the with the company ID 2, which belongs to the healthcare sector. So with the company 2 has a revenue of 7,500 in February. So the average revenue for healthcare is 7,500 here, as there is only one transaction. So I hope you understood the input table and the output tables over here. So let's now move on to the steps to solve this. You can also pause the video here and just think through, just brainstorm like what steps we can follow to just solve this problem, and what kind of SQL functions that you'll be using to solve this problem. So let's now move on to the steps part. So our first step would be to create a CTE to extract month and filter by year. So in this very step, we will just create a common table expression to extract the month from the transactions date and filter only the transactions that occur in the year 2020. So in this CTE, we can also calculate the average revenue for each company within the same month using the average function with the window function to compute the average monthly revenue for each company. So this is what we will be doing in the step 1. Now in the step 2, we will just join the CT that we just created in the step 1 with the sectors table. So after creating the CT with the filtered and grouped data, we will just join it with the sectors table using the company ID.
So what this join will help us? So this join will help us ensure that each company's revenue data is matched with the corrected sector. Now in the step 3, we will just group the data by month and year. So after joining the tables in the step 2, we need to group the data by month and sector. So this is necessary to calculate the average revenue at the sector level for each month, since we want to calculate the average revenue for the combination of sector and month. So in this step, we will just perform the group by function. And in the last step, we will just order the results. So since we need to order the results first by month and then by sector, so this will just ensure that our output is in the chronological order for each month and the sectors are listed over there. So that's how we are just going to approach our solution. So let's now move on to the implementation part. So we will be solving this question in MySQL workbench over here. So guys, as you can see, here is my input tables, the transactions table and the sectors table. And now from the steps that we just discussed, we are going to apply CT. But for now, let's first do it without CT, and then later on we will just discuss another approach using CT. So for now, we just want to join the tables on the company ID column, because the company ID is something which is common in both the tables. So let's first join the tables. So first of all, select, I'll just write star for now, since I want to retrieve all the records from transactions table, transaction as T, and the second I'm going to perform in a join, say sectors as S on company ID. So T dot company ID is equal to S dot company ID. So if I just run this query, you see that each company's revenue data is matched with the corrected sector. So whatever the columns that I want to retrieve here is, I'll just going to write that. So the company ID I want. Second, I want to extract the month from the transaction date. So I'll just do that. So I am going to apply extract function. So extract month from transaction date. So I will just give the alias as month. Okay. And so since in this case our goal was to calculate the average monthly revenue for each sector in the year 2020 for every month, so here I am going to apply the average function to compute the average revenue. So here in this case, let's just calculate the average of revenue. So revenue is from my transactions table. So T dot transactions, average of revenue is going to be average revenue. Now I will have to apply the group by clause. No, but before applying to the group by clause, I had one condition that my year has to be 2020. Although by default in the input table the year is already 2020, but compute the uh, corrected results, we will have to apply this condition. So where extract year should be, so year from transaction date. So the year has to be 2020, and then I can just directly apply my group by clause. So since I want to compute the average revenue for the combination of month and sector, that's why I'll be applying the group by clause on sector and month. But as you can see that we have not extracted our sector column here, so I'm just extracting that. So S dot sector. So this is my month. So I have applied group by sector, and since we don't want company ID now, we only wanted sector, month, and the average revenue in our output. So I'm just writing that here. So if I just do that, Okay, so it shows comma. It has to be comma now. So if I just do this, what we will be getting is our final output. So as you can see that here we have just presented our output to compute the average revenue for the combination of sector and month. Now in this case what we did is, first of all we just joined both the tables. So in this step we just joined the transactions table and the sectors table using company ID column, which is the common field, because the transaction table has revenue data and it lacks information about which sector each company belongs to. So since we wanted to compute the revenue uh, at the sector level, so that's why we just performed the join here. And in the second step we applied the extract function on the month and filter, because we wanted to extract the month as well as we wanted to extract the year has to be 2020. So we just applied that here. So we just applied the function extract to compute the month and the year. And lastly, here we just grouped and aggregated the data. So after joining the tables and filtering the data, we just applied the group by clause on both month and sector column here at the last. So grouping by month ensures that revenue is calculated for each individual month, while grouping by sector allows us to focus on revenue at the sector level. And this was our requirement, since we wanted to compute the average revenue for the combination of month and sector. So that's why we just applied the group by clause on the month and sector. So once our data was grouped, we just applied the average function. So average function to compute the average revenue for each sector within each month. So this actually gives us the desired result for monthly average revenue per sector. And at last, if you want to do order by, you can do that. So order by on month and sector, that you can do. But let's discuss the another approach, which was using a CTE. So now to get my final output, I need to first create a CTE to extract the month, and then we will just filter it by the year 2020. So let's just write a CT to extract the month from the transaction date. So to extract the month from the transaction date, we will be using extract function on the transaction date column. So let's do that. So I'm just writing a CT. So I'm just giving my CT name as monthly, and whatever the columns that I want to retrieve, I'll just write it afterwards. So this is my transactions table. So since I want to extract, so if I just run this table, so this is my transactions table. So what I want from my transactions table here is, I want the month from the transaction date. So I will just write the extract month from transaction date. So what this will do is, it will actually extract the month from the transaction date. So I'm just giving it alias as month. Now the second thing that I want is the company ID as it is. So if I just run this query, what I'll be getting is, so this is my month and this is my company ID. And for this combination of month and company ID, I want to compute the average revenue. So let's compute the average revenue. So to do that, to calculate the average revenue, so we can just apply the average function with a window function to compute the average monthly revenue for each company. So I'm just applying the average of revenue over partition by, so it should be partitioned by month. So it should be partitioned by month and company ID, right? So to partition by month, I cannot just write month over here, because this is just an alias that I just defined. So I'll have to write it completely, the extract month from transaction date as month, and should be partitioned by company ID as well. So based on this combination of the month and company ID, it will just calculate the average revenue. Here I have to close this parenthesis. Fine. So we don't want to write it write this as month. Okay, I hope it's clear. Yeah, fine. So now as I computed this, so if I just run this query, you can see that we have got the results, but let's just give it as some alias because it's too long here. So this is your average revenue. Now if I just run this, you will see that this is your average revenue. Also, one condition that you have to apply by default, it is already the year 2020 in the input tables. But if in case you're working on a long data set which has too many rows, so in that case, that there might be different years. So here we will have to apply the filtering condition. So where your year from the transaction date should be 2020. So here I will just extract year from transaction date column. So this year should be 2020 since this is already given in my question. And I'll just close my CTE here. So this is the CTE that I just wrote. Now from this CTE, I have to join it with the sectors table since I want to compute the sector, month, and the average revenue in my output. So I'll just join it on the company ID. So let's just join this. So here I'm just writing select statement from monthly, the above CTE, monthly as M, and I will just join it. So I'm just going to perform inner join here. So sectors as S, and I'll just do it on my company ID. So on M dot company ID is equal to S dot company ID. And the column that I want to retrieve, so I can just write M dot month because I want to retrieve month from my monthly table, and S dot sector that I want to retrieve sector from my sector table, and the average revenue. So the average revenue I want to retrieve M dot average revenue. So here M dot average revenue. So it's going to be the same average revenue. Fine. Now if I just run this query, complete query, let's just run this and see that we have got our expected output, although we have not performed the group by function. So here we have to apply the group by function. So here as you can see that we have computed the month, sector, and the average revenue, but as you can see that we have to calculate the average revenue corresponding to each month, sector, and the respective average revenue. But in this case, as you can see, for the month of February, technology sector, so you can see two columns over here. So here month 2 technology, again month 2 technology. So in this case you have to compute the average. This is not the actual average, so this is just the revenue. So let's compute the actual average here after grouping the data. So let's perform the group by. So we'll be applying group by function on the month and sector. So month comma sector. So month is from my M dot month and sector is from my S dot sector. And after applying this group by function, I'll just compute the average of this. So average of this revenue is going to be my final average revenue. Now if I just run this query, it should get my expected output. So as you can see that it has computed the average revenue now. So this was my expected final output. So I hope you're clear with the solution. If you want to, if you let's just go through the summary of the approach again. So first of all, we have just created a CT that extracts the relevant month and filters data to only include in the year 2020. It also calculates the average revenue per company for each month, but not specifically for the sector. So it has just computed the average revenue per company for each month. And in the second step, we just joined between the CT and the sectors table to analyze revenue at the sector level. And in the third case, we just grouped by month and sector to compute the final average revenue for each sector per month, for each sector per month. So here in this case, the sector is included since we wanted to compute the final average value for the combination of sector and month. So in this case, we had to apply the group by on the month and sector, and then we computed the final average value over here. So the question is on finding the top 5 artists whose songs have appeared most frequently in the top 10 of the global music charts. So in this case, we will be using three tables: artist table, songs table, and the global song rank table. So let's understand the problem. So we are given the artist table over here. It contains information about artist, including their unique IDs, that is artist ID, names, which is nothing but the artist name, and the music label they are with. The second table is the songs table, which contains song details like song ID, artist ID, which links to the artist who created the song, and song's name. And the third table is global song rank table. The table holds the daily ranking of the songs globally. So it has columns like day, song ID, and rank. The rank column indicates the song's position on that day with a lower number representing a better rank. So now the question is to identify the top 5 artists whose songs appear most frequently in the top 10 of the global song rankings. And also it is important to note that if multiple songs from the same artist are in the top 10 position, they should all count towards the artist total appearance. Also, we want to rank these artists based on the number of times their songs have appeared in the top 10. And if in case there are ties, they should have the same ranking, but the overall ranking number should remain continuous. Means that if two or more artists have the same number of appearances, they should be assigned the same ranking, but the ranking numbers must remain continuous. For example, the ranking 1, then for example, if it is ranking 2, 2, 2, and then the rank should continue with the ranking 3 and so on. So let's now just understand what is the input table and what is the output table. So as we can see, we have the artist table, we have the songs table, and we have the global song rank table. And since we want to identify the top 5 artists whose songs appear most frequently in the top 10 of the global song ranking. So if we see for the artist name and the artist ID, so if we see for the artist name Ed Sheeran, with the artist ID 101, so we can see that in the songs table, this particular artist with the artist ID 101 has two song IDs, that is 55511 and 45202. Now if we see for the global rank of these songs, so for the 55511, we can see that there is only one appearance for the song on day 1 and the rank 8. And since it is under top 10, since the rank is 8, so we will be considering this appearance. And the second one is for the song ID 45202. So we can see there are two appearances for this one, with on the day 1 with the rank 5 and on day 3 with the rank 2. So since both the ranks are under 10s, so we are going to consider them as well. So for this particular artist, with the artist ID 101, we have in total 3 appearances. Now if we see for the second artist, which is Drake, with the artist ID 120, so we can see that in the songs table, it is associated with two songs IDs, two different song IDs. One is 22222 and the second one is 19960. Now, if we see the global song rankings of these particular songs, which is triple two double two, so we can see that there is only one appearance for that on the day 5 in the rank 7. So since the rank is under 10, we are going to consider this appearance. Now, if we see for the 19960, we can see that there are two appearances on the rank on the day 1 with the rank 3 and on the day 9 with the rank 6. So in total, we have three appearances for this particular artist as well. So for the artist ID 101 and for the artist ID 120, we can see that three appearances are there in total. Now, if we go to the third artist, which is Bad Bunny, with the artist ID 125, we can see that there are two songs associated with the same person with the song ID triple three double two and triple four double four. Now, if we see for the global rankings for these songs here, for the triple three double three, there is only one song associated with one ranking associated with this song, so which is on the day 2 and the rank is 4. So this is also we are going to consider, and along with that we can see for the song ID triple four double four, again has also one appearance which is on day 4 and the rank 10. So since both the ranks fall under the category of top 10, so again we are going to consider these, and the total number of appearance for this is 2, as we can see, with the rank 4 and with the rank 8. So the total song appearance for Bad Bunny is 2. Now, if we see for Lady Gaga, it is with the artist ID 130. Now, if we see for this particular artist, there are two songs, which is triple five double five and two song IDs, that is triple five double five and triple six double six. Now, if we see for the same, we can see there are two song IDs over here in the global song rank table, and since both are under 10 with the rank 1 and rank 10, so we can see that both of them fall under the filter option that we have, that should be under top 10. So again, the total appearance for this particular artist is also 2. Now, if we see for the last one, we can see the with the artist ID 140, Katy Perry. So we can see that there are two song IDs associated with the same, that is triple nine double nine and 101010. So if we see for the global song rank table, we cannot see any song IDs with the song ID 1010, and but there is one with the triple nine double nine, which fall under the rank uh, with the rank 5, that is under rank top 10. So we can see that there is only one appearance of this one. So in total, if we see, there are three appearances for artist ID 101 and 120, two appearance for artist ID 125 in 130, and one appearance for the artist ID 140. So since our question was to find out top 5 artists whose songs appear most frequently in the top 10 of the global song rankings, so we are just going to rank them. So this is how our output should look like. The artist, this should be rank 1. Ed Sheeran and Drake should be rank 1, since they have total 3 appearances. Bad Bunny and Lady Gaga should be ranked 2, since they have 2 appearances. Both have same number of appearances. And Katy Perry should be ranked 3, as it has only one appearance, one total appearance. So this is how our output should look like. Now you can think through the solution, that what approach we are going to follow and what SQL functions we are going to use over here to solve this problem. You can even pause the video here. So let's just move on to the steps part. So if we see for the steps, we are our first step would be to, since we have three tables over here, so we will just join the tables. We will just join the artist table with the songs table on artist ID, which is the common column in both the tables, and then we will just join this result with the global song rank table on the song ID. So what this will help us to match each artist with the songs and find out how those songs are ranked globally. Now in the step 2, we are just going to filter for top 10 songs, since we only want to include rows where the rank is less than or equal to 10, as we are only interested in songs that are in top 10 category. Now, in the third step, what we are going to do is we want to count the top 10 appearances per artist. So now that we have the list of artists whose songs are in the top 10, as we already filtered out in the step number 2, we need to count how many times each artist's songs appear there. So in this step, we just group the results by artist name, and we will just count the number of times each artist's song appear in top 10. And in the fourth step, uh, we need to rank the artist based on these counts that we actually did in step number 3. And so we will just make use of dense rank function to do that. Dense rank is a window function in SQL. So since we have been given to handle ranking properly, especially in cases when multiple artists have the same count of song appearances in the top 10, means if 2 or more artists have the same number of appearances, they should be assigned the same ranking, and the ranking numbers must remain continuous. That means we don't want to skip the ranks. So in this case, we are going to use dense rank function, as the number continues sequentially without skipping the ranks. Now the step 5 would be to finally select the top 5 artists. So in this case, we will just filter the ranked artists to get only the top 5. So what we will be doing is we'll use a common table expression to simplify this process and make the query more readable. So what we will do is we will use a CT to first get the artist and their ranks, and then we will just select only those with the rank of 5 or less. So so this is how our solution steps are going to follow. So let's move on to the implementation part over here. So guys, as you can see, I have already imported my all the 3 tables: artist table, songs table, and global song rank table. So if I just run this, as you can see, my table has been imported over here. Now if I just run this query, I can see my songs table is here, and if I just run this one, you can see my global song rank table is also displayed over here. So since that we have to identify the top 5 artists whose songs appear most frequently in the top 10 of the global song rankings. So let's first join the tables, as this was our initial step. So let's first join the tables. So select, let's say I just want to retrieve all the records, and I want to join the tables. Artist table, I'll be doing inner join on the songs table. Next, this has to be done on artist ID, since that is the common column. So I'll just give the alias as A, and for this I'll just give as alias as S. So A dot artist ID should be equal to S dot artist ID. Now I want to join with my another table, which is my global song rank table. Global song rank table, and I'll just give it as alias G, and we have song ID, which is the common column in both of these. So I'll just join it on the song ID. So S dot song ID is equal to G dot song ID. And since we wanted to filter, so let's just run this query first. So what we have got is we have got all the columns from all of these tables, and we have got the rank as well. Now since we only wanted to filter only with the top 10 of the global song ranking, so I'll just apply my filtering condition over here in the where clause. Since we only want to include rows where the rank is less than or equal to 10. So what as we can see from this is just a kind of input sample input data set. But if if you go for the larger data set, you can find rankings which are more than 10. So if this, in this case, by default it is already 10, but we are going to apply this condition in this as well. So my ranking, which is rank column, rank should be less than equal to 10. So this is from my G table, so G dot rank. Okay, now if I just run this query, I'll get the same result because all of those are, the ranks are already under top 10, all the ranks. But now my my next step was to count the song appearances, and rank the artist. So what we will do here is we will just group the results by artist name and count the number of times each artist song appear in the top 10. So let's just do the group by on artist a dot artist name. And since we wanted to give the ranking as well, so let's just give the ranking using dense rank function, as we already discussed that here we have the list of artists whose songs appear in the top 10 position. So we just need to count how many times each artist song appear over there. So I will be using dense rank function. So what in, I'll just removing the star, and I just want to find the artist name, and the next one is dense rank function, which is my window function, and I will be applying it over. So what I will be doing is here I will just do order by count of s dot song id. It should be in descending order as artist rank. Why descending order? Because the highest rank should be highest count should be rank 1. If there are as we already counted for this one, as we can see for the Ed Sheeran, we have 3 appearances, so it should be given rank 1. So that's why we are doing order by count of song IDs in the descending order. So this is how it will just give us the rank. So if I just run this, what it will do is it will just do something like this. So it has already given the ranks over here. So since we only want to find the top 5, since by default in this case it is already top 5, but we have to follow the steps that we have to filter out the top 5 artists. So what we will do is we will just create this as a CTE. So this is my CTE, say CTE as, I'll just create this in my CTE, and from this CTE I will just select artist name I want, and artist rank I want from my CTE. So from this CTE, I only want to retrieve my top 5 artists, so I can just use the limit function over here, limit 5. So it will just give me 5 rows. If you see that if the question is like you just want to retrieve the top 3 artists, so you can just use limit 3. So it will just give you top 3 rows of the artist. So if I just run this query, it is giving me top 3, and if I just run top 5, limit 5, it will give me top 5. So this is how you are going to approach this question. So in the first step, what we did is we actually joined the tables on the common columns, the artist table, the song table, and the global song ranking table. just to make sure that each artist is associated with their songs and find out how those songs are ranked globally. And in the next step, what we did is we actually filtered out for the global song ranking that should be less than or equal to 2, because we are only interested with the artist whose rankings fall under top 10 category. And the next step that we did is we want to count the song appearances, and based on that we wanted to rank the artist. So we use the group by clause on the artist name, and then we just count the number of times each artist songs appear in top 10 using the count function, count on song id. And then we want to give them rankings as well, so we just applied the dense rank function to do that. And why dense rank function was applied, because the dense rank function actually does not skip the ranks. And for example, if two artists have the same count of songs, they receive the same rank, and the next rank number continues sequentially without any gaps. So that is why we have applied dense rank function. And here we have done the order by in count of song id in descending order, to make sure that the highest number of song appearances should get lower rank, that is with the highest number should be get rank 1, as we can see over here. As Ed Sheeran had three total song rankings, three total appearances. That's why the artist rank is 1. The same was the case with the Drake. So both of them got assigned with the rank 1. Now, in the last step, what we did is we actually, since we only wanted to filter out the top 5 so we have just created this as a CT, and from the CT we have just applied our limit function to just display the top 5. If you think you wanted to display top 2 or top 3, then you can just make just apply the limit 3 or limit 2, either any of those. So the question is on finding the third highest salary of employees for each job category. So let's understand the question in detail. So we are given some employee details having columns like employee ID, first name, last name, salary, and the job category. And we have to write a SQL query to display the details of the employees who have the third highest salary in each job category. And we have to return the columns like employee ID, first name, and the job category. Also, the result should be ordered by employee ID in descending order. And this is how your output should look like. So let's just take a look at the data more in detail. So this is the data that we have, and as you can see, we have various job categories like DEV, HR, FIN, PDT. So DEV stands for development, HR stands for human resources, FIN stands for finance, PDT stands for product development. And as you can see, you have 4 employees in the development category, 4 employees in the HR category, 3 employees in the finance category, and again 4 employees in the product development category. So since we have to display the details of the employees having third highest salary for each job category, so let's just take a look at the salaries of the employees. So if we see for the development category, the highest salary is of the employee ID 108 having salary 62,000. The second highest salary is of employee ID 102 and it is 60,000. And now if we see for the third highest salary, it is of this employee 104 named Charlie having the salary 58,000. So this is the record that we would like to display in our output with the employee ID 104, the employee name Charlie, and the salary 58,000. Similarly, if we see for the HR department, the highest salary is of both employee ID 103 and 105 having salary 61,000. So this is the first highest salary. Now the second highest salary is of 57,000, which is of the employee ID 107, and the third highest salary is of employee ID 109. So since we want to display the third highest salary, and this is the record that we would like to display, which is the of the employee ID 109 and the employee name Zodi. Now if we see for the finance department, so the first highest salary is 70,000, the second highest salary is 72,000, and the third highest salary is 65,000, which is the Olivia with the employee ID 113. Now, if we see for the product development department, the third highest salary would be 64,000, because the first highest salary is 68,000 and the second highest salary is of two employees, which is 66,000. So we would like to display the third highest salary of the, which is nothing but 64,000, and that belongs to employee ID 114 having name Lucas. So this is how our output should look like. For the HR category, as we already discussed, the employee ID 109 and the name Judy. And for the development category, it was Charlie. And for the finance category, it was Olivia. And for the product development category, it is Lucas. So now let's just move on to the what steps to follow to solve this question. I suggest you to pause the video here to brainstorm and understand what methods you can apply and what functions to use to solve this problem. So let's just move on to the steps. So the first step would be to write a CTE to display employee records along with the ranking based on their salaries within each job category. So this step is achieved by using the dense rank window function. So using that, we will be able to display the rankings based on their salaries within each job category. Now the second step is that we already discussed. We are just going to use the dense rank function to display the rankings based on the order of the salary in descending order. And here, since we have to find the third highest salary for each job category, so we will be partitioning the data based on the job category. So we will have to apply the partition by clause on the job category column. Also, as we have to find the third highest salary, so we will use the order by clause for the salary column in the descending order. So dense rank function is nothing but the SQL window function that we are just going to use over here, and we will just write the CTE, just find the rankings of those. And in the last step, what we will do is we will just filter the results to only include the rows with the ranking is equals to 3. That means it will only display the details of the employees who hold the third highest salary within each job category, and that's what we want in our output. So let's now move on to MySQL Workbench for the complete implementation. So guys, as you can see, I have already imported my employee table here. So if I just run this query to display all the records of my table, this is the output I got. So as you can see, I have 3 employees in the development category. 4 employees in the development category, 4 in the HR, 3 in finance, and 4 in product development. So now, since we have to as we have to display the details of those employees having third highest salary in each job category, so to do that, as our first step was to write a CTE that contains the employee records along with the rankings based on their salaries within each job category. So we will just write a CTE. So let's just name the CTE as ranked employees. So this is the CTE ranked employees. So this is my CTE name, and here I will just write my query. So select, I want to display the employee ID, first name, and job category, salary, and since I want to display the rank, so to do that I will be using dense rank function as we already discussed. And the dense rank functions over. So in this case, since I want to display the details of the employees for each specific job category, so to do that I will have to do the partitioning on job category column. So we will be doing the partition by clause. We'll be applying the partition by on job category column. Also, we have to do order by salary in descending order, since we have to display the third highest salary. So order by salary in descending. So I will just give this this new column as the alias rank RNK, and I will take it from the employee table. So this is the CT that I just wrote over here. So if I just run this query within the CT that I just wrote, sorry guys, yeah. So if I just do that, you can see that the rank has been given. So if you see for the development category, 1, 2, 3, 4 is the rank. If you see for the finance category, you can see 1, 2, 3 is the rank. If you see for the HR category, the same salaries has been given the same rank, which is rank 1, as you can see over here. I'll just and if you see for the product development job category, as you see, this belongs to the same salary, so the same rank has been given, which is the rank number 2 here. So we can say that we have displayed the employee records along with the ranking based on the salaries within each job category. So now we have to just filter out the employees having rank is equals to 3. So here I will just select whatever the column that I want to retrieve. I will just write that, which is my employee ID should be there in my output. Second column was the first name I wanted in my output, and the job category I want in my output. From, so here I will write my CTE name, which was ranked employees, right? Yeah, this was my CTE name, and here I will just do where my rank is equal to 3, and at the last I will just have to do the order by on the employee ID, since that was written in the question itself that our employee ID should be in ascending order. So if I see the query here, what I first did here is I just wrote a CTE named ranked employees that contains all the employees records along with the ranking, with having the alias as R and K based on their salaries within each job category, and this is achieved using dense rank window function. So what the dense rank function does is it assigns the same rank to employees within the same salary, within the same job category, and does not skip any rank number. So if you can see here, it gives the same rank to this person having the job category HR with the same salary, that is 61,000, that belongs to two employee IDs 103 and 105. It has not skipped the rank, is giving the same rank here. So we have used dense rank function. Now what in the next step I have done is I have just filtered the results to include only those rows where rank is equal to 3 using the filtering condition, which is the using where clause, where R and K, that is rank, is equals to 3, which means that we are interested in employees who hold the third highest salary within that job category. And at the last we have just sorted our result based on the employee ID in ascending order. So if I just run the final query here, I have got the same result which I was expecting. So that's about the answer of this question. We have used CTE to solve this question along with the window function, that is dense rank function. Now there is one important thing that is very important to note, that why we have used dense rank function and why we have not used other window functions like rank or row number function. So in this case, dense rank function is used because it assigns the same rank to employees with the same salary within the same job category, and it does not skip any rank numbers. For example, if two employees have the same salary and are both ranked first, the next highest salary will be ranked second, not third, which would actually happen in rank. So if so I will just help you explain, like if I just apply the rank here, so what it will do is, if I just run this thing, I'll just help you understand. If I if I'm not using dense rank, instead I'm using rank, and if I just run this query, see the ranks. So if you see for for the duplicate for the same salaries, if we see here, so for the HR department, the salary is 1 for the 61,000, but for the next employee, which is having 57,000, it should have been given the rank 2. But here you can see that it has been given rank 3. That means this salary, the rank has been skipped over here. Instead of giving the rank 2, it is giving the rank 3. So what the rank function does is, rank also assigns the same rank to ties. So here in this case, to ties, it has given this, that is rank 1, but it has skipped the next rank number where there are when there are ties. For instance, like we see for the employees are ranked first due to identical salaries, the next employee should be ranked 2, but here in this case it is skipping the rank and it is giving the third rank, and henceforth fourth rank to the next employee. So since in this case the Judy has been given rank 4, but it actually belongs to rank 3. So this is the case with the rank function. So we can see that the result comes in gaps, which is not desirable when looking for the third highest salary specifically. That's why we are not using rank function. Now there is one more function, that is row number function. So if we apply the row number function, what it does is, so let's also see that. So if I just apply the row number function and if I just run this query, let's see the rankings over here. So what the row number function does is, row number function assigns a unique sequential number to each row without considering ties. So in even if there is some ties, it is not going to assign the same rank. Instead, as you can see with the salary same 61,000, you can see the ranks are different, 1, 2. So it does not provide the same rank to employees with identical salaries. That means the employees with the same salary will have different rankings. And this function is not at all suitable for this scenario because it does not handle ties and rankings. So the ideal scenario is with the dense rank function, which does not skip any kind of rankings. So that is why we are using dense rank function. So again, I'm saying that this question is really important and is asked in many companies, and if they are not asking you to write a query, they will definitely ask you the difference between the rank, dense rank and the row number function. So please keep that in mind. So as you can see, we have got the answer. So I hope the solution is helpful to you. In this case, we have used CTE, and if you think that you can do it using subquery and another approach, please let me know in the comment section. So in this case, we have to find the SuperCloud customer. So let's get started with the question. So in this case, you are given the details of the customers and the products purchased by them. So in this case, you have been given two different tables. One is the customer contracts table. This is the name of the table, and which contains records. This table contains records of each customer purchase details, including the customer ID, product ID, and amount. So these are the columns which are present in this particular table: the customer ID, product ID, and the amount. And the second table is the products table. So this table provides information about each product, including product ID, product category, and product name. So it has again three columns, that is the product ID, what category it belongs to, and what is the name of the product, which denotes the product name. Now you have to identify the customers who have purchased at least one product from every product category listed in the products table. So you have to write a query to find the customers who have purchased at least one product from each product category, from every product category which are mentioned in the products table. So let's see the sample input and sample output table. So if we go to the customer contract table, since I already told, we have three columns: the customer ID, product ID, and the amount. So here the customer ID is nothing but the ID of the customer, product ID is the ID of the product which the customer has purchased, and the amount is the one which the customer has paid to purchase the product. Now the second table was the products table, which had the details of the products, which contains product ID, product category, and product name. So here, and now since your task was to identify the customers, that means to identify the customer IDs of those customers who have purchased at least one product from every product category listed in the products table. So now let's go to the customer IDs one by one and see whether those customer IDs have purchased each at least one product from each product category. So now, if we see for the products category column, there are three products category that we can see. The one is the analytics, the second one is the customers, and the third one is the compute. So there are three distinct product categories in our sample input table. Now, since we have to find the customers who have purchased at least one product from each product category. So if we see for the customer ID 1, so the customer ID 1 has purchased the product ID 1, which belongs to analytics category. Okay. Now if we see for the customer ID 1 again here, he has purchased product 5, product ID 5. So the product ID 5 belongs to the compute category. And then if we again go to the customer ID 1 here, he has purchased the product ID 2, which again belongs to analytics category. So now the thing is, the customer ID 1 has not purchased any product that belongs to containers product category. So this customer ID cannot be there in our output, because we want the customer IDs of those customers only who have purchased at least one product from each product category that are listed in the products table. So now if we go to the customer ID 2, let's search for the customer ID 2. If we see, the customer ID 2 has purchased the product ID 2, which belongs to analytics category. And now if we see for the customer ID 2 again here, he has purchased product ID 5, which belongs to compute, that means analytics compute. Now if we see again the customer ID 2, we cannot see any kind of customer ID 2 further. So that means the customer ID 2 has also not purchased any product from the containers category. So this will also not come in our output. Similarly, if we see for the customer ID 3, there is only one product purchased for the customer ID 3, that is the product ID 1. So this will also eliminate and will not be there in our output. Similarly, if we see for the customer ID 4, the customer ID 4 has purchased the product ID 1 and the product ID 5. Again, it has not purchased any product from the containers category. Similarly, if we go to customer ID 6, 5 is not present here. So if we go to customer ID 6, there is only one transaction made by the customer ID 6. So again, this will also not come in our output. Now if we see for the customer ID 7, we can see that customer ID 7 has purchased the product ID 1 that belongs to analytics category. The customer ID 7 has purchased product ID 3 that belongs to containers category, and the customer ID 7 has also purchased the product, which is the product ID 6, which belongs to compute category. So in this case, the customer ID 7 is something that is satisfying our condition. That means the customer ID 7 has purchased at least one product from each product category from these sample input tables. So that we can say that the customer 7, that is the customer ID 7, has bought from analytics product ID 1 and customers containers product ID 3 and compute, that is the product ID 6 categories of Azure, and this is our super cloud customer. So the customer ID 7 will only come in our output. Okay. So super cloud customer is the only one who has purchased, I mean, whatever the condition that we have already told that it should have purchased at least one product from each product category. So that customer will be said to be the super cloud customer, just for the clarification, if in case you just got confused with the super cloud customer here. So I hope you understood how it has been calculated. Now the thing is, since we have to write the SQL query, so what will be our approach? What things we can do? What are the columns? How will we join these tables? So now, if we see for both the tables, we can see that product ID is something which is common in both the tables. So we can just combine the information from both the tables. Okay. So what steps will we follow is the first of all, uh, even you might also just pause the video here and think through it, like what can be the ideal steps to follow to write the SQL query. And by the next second, we will be solving. We will be just I'll be just telling you the approach to solve this problem, and later on we will write the SQL query of MySQL workbench. So now the first step will be to combine the information from both the tables. That means we will join the customer contracts table with the products table to get the product categories associated with each customer purchase. So if we combine these two tables, we will be able to find the product category with for each customer purchase. And then what we will be doing is we will just count the distinct categories per customer. Now, in order to count the distinct categories per customer, we will just group the data by customer ID, and then we will count the product category values for each customer. And at last we will just compare our distinct categories, the count of distinct categories per customer that we just calculated. We'll just compare it with the total number of categories. Okay. So if in case the count comes out to be equal, if in case the count comes out to be equal, then those customer IDs will be there in our output. So what we will do is we will just compare with the total number of categories just to ensure that the count of distinct categories per customer is equal to the total number of distinct categories present in the products table. So this will make sure that this customer ID is purchased each each and every each sorry each at least one product from each product category. So this is how we will be doing it. So now let's write our query in MySQL workbench, and then we will just I'll just help you with the each and every step. So let's start. So guys, moving on to MySQL Workbench, here I have already imported both the tables, the customer contracts table. If I just run this query, it will give me all the columns which are present in customer contracts table. So since we already discussed, it contains three columns: customer ID, product ID, and amount. And if I run this products table, again we will get all the details of the products table, which contains these three columns: product ID, product category, and product name. So now the very first step was to combine these both the tables. So we will be joining these both the tables, and we will be using left join for this, because since we want the customer IDs, so we will have to consider all the customer IDs. So we will have to consider all the records from the left table and only the product category. I don't think product name is something which is relevant in our case. So we just our focus will be on only on the product category. So let's do the left join on from customer contracts table and the products table. So here I'll just write my select from. So my first left table here is customer contracts and aliased SC, and then I'm just doing left join, and I'm doing it with the products table aliased as P, and I'm doing it on the product ID column, which is the common column of both the tables. So C dot product ID is equal to P dot product ID. So now whatever the records that I want all the records from my customer contracts table. So I'm just writing C dot start. So this will give me all the columns which are present in customer contracts table, and I only want product category product ID will already come because it is the common one, and I only want the product category, so I'll just take the product category from the products table. So I just this. So if I just run this, what is something that we will get is, we have got the customer ID. For each customer ID, we've got the details of the product ID and the amount they paid and the product category. Okay, so now the second step was to count the distinct categories per customer. I mean, for each customer, let's say for customer ID 1, what distinct categories have they purchased. So we will just count the number of distinct categories per customer. So now let's from this table we will be using, so let's make it as a CTE with CTES. So I've just made it as my CTE. So now from this table, from my CTE, select from CTE. Okay, I want the customer ID in my output. And since to count the distinct categories per customer, we will have to group the data by customer ID, and then we can just count the distinct product category values for each customer. So here I'll just do my group by operation on my customer ID column, and then I'll after doing the group by clause, after just grouping on the customer ID column, I'll just find the count the distinct product ID product category values for each customer. So I'll just make use of having count of distinct product category. Okay, now since I told that this count should be equal to the total number of categories which are present. So to find the total number of categories, just writing the query here to find the count of distinct product categories which are present in the products table. So here we will only consider the products table. So select from products. Now since we here the count of distinct product category, and here we will just count distinct product category from the product table. Okay, so we are just comparing. So for each customer ID here, we are finding the count of the products purchased in each category. So like for the customer ID 1, it will come out to be 2, and then for the customer ID somewhat like that, it will just count the distinct categories that each customer has purchased. Okay, and the last one, this subquery will count the total number of distinct product categories available in the products. So in the input table it was 3 distinct categories, but we don't really know about the data set that we might work on. So there may be different product categories. So in this case we're just comparing the product category, so that should be equal. So I'll just see this, just 1 second. What y cross is here? Okay, this will be in a separate. Okay, cool. So now if I just run this query, what I'll be getting is the customer ID 7. So this is what we wanted, the customer ID 7 in our output. So in this case, what we have done is, first of all, we have just we've just joined both the tables, that is the customer contracts table and the products table, we did the left join, and we found for each customer ID, the product category, the product ID, and all these things. Now from this particular table we have just created, we just write it as a CT because this is something that we want to consider. So I just made it as a CTE, and CT is nothing but a temporary result set, we can say. So in the CTE, we have now from the CTE we have just selected, we have written our query here. Our query starts from here, the second query here. I mean, that is the complete one query. So apart from the CTE, we are just extracting the customer ID from the CTE on a condition that are the count of distinct product categories per customer. The count of distinct product categories per customer should be equal to the total number of distinct product categories which are present. So if we just compare it, if it comes out to be equal, that means that that is the customer who has purchased at least one product from each product category which are present in the products category table. So here we have just done the group by operation on the customer ID column, and here our main query, we have just extracted the customer ID. We had to do the group by operation to aggregate the data per customer so that we can just count the distinct categories each customer that has purchased. And then we have just written our subquery here just to make sure that we can count the total number of distinct product categories available in the products table from the products table here. So I hope you understood the solution. If in case you still have doubts, please let me know in the comment section. Analyzing restaurant ratings over time. So let's understand the question first. So imagine that you're working as a data analyst with Zomato, and your task is to analyze restaurant ratings over time to understand how the average rating of each restaurant changes monthly. So basically your objective is to calculate the average rating of each restaurant for each month. Also, you want to include restaurants that have received at least 2 reviews in a given month. So this is a kind of condition that you have been given, and based on this condition you have to filter the data. So let's understand the data set. What is the input table over here is, you are given reviews table with the columns review ID, user ID, submit date on which the review got submitted. The restaurant ID is the ID of the restaurant, and this is the rating that has been given by the user. Now, since you want to calculate the average rating for each restaurant for each month, and since you have to include only the restaurants that have received at least 2 reviews in a given month, so your output should look like this. It should have columns like month, restaurant ID, and the average rating. So basically you want to calculate the average rating for each combination of month and restaurant ID, given that you should qualify the condition that it should have at least 2 reviews in a given month. So if you see for the input table, we can see there are 2 types of restaurant with the ID 101 and 102. And for these restaurants, the review details have been provided over here. So if you see for the restaurant ID 101, there are 5 reviews, 5 rows of reviews in total. And if you see for the submit date, there are the 2 reviews are in the month of January, as you can see from here, January 2022. 2 reviews in the month of February 2022, in 1 review in the month of March 2022. And since we only want to include the reviews, include the restaurants that have at least 2 reviews in a given month, so we will not be including the March one, and we will be only including the January one and the February one with the month 1 and 2. And as you can see, we have that only in our output with the month 1 and 2 having restaurant ID 101 with the average rating. So now if you see for the restaurant ID 102, So for the restaurant ID 102, you can see that there are 2 reviews in the month of January and only 1 review in the month of March. So again, we are not going to include this one for the month of March and only going to include with the month of January, because this is the only one that qualifies our condition that should be having at least 2 reviews in a given month. So the average rating has come out to be 3 plus 4 divided by 2, that is nothing but 3.5. So this is how we are going to calculate our output. So how what conditions that we are going to follow, you can just think through the solution, you can think through the approach that what SQL functions you are going to follow to write the query to get this output table from this particular input table. So let's now move on to the steps. So our first step would be to extract the month from the review submit date. So as you can see that you have one column of submit date. So from that you can just extract the month from that submit date using month function if you are working on MySQL Workbench. But if you are working on Postgres SQL, then you will have to apply another function, that is date part function. So that's how you can just extract the month. And the second step would be to use the average function to calculate the average rating. So this is very generic one, since you want to calculate the average rating. So obviously we are going to use the average function. Now the third step would be to group the data, since we want to calculate the average rating for each restaurant for each month. So there should be a combination of the restaurant and the month. So that's why we would like to group the data on the restaurant and the month, restaurant ID and the month. And in the next step, we are going to filter groups with a having clause, since it has been given that you should only include the details of those restaurants that have at least 2 reviews in a given month. So here you will have to use the count function on you will have to use the count function uh, to just count on the review ID to so that it will help you to just filter out the groups with the having clause. So that's all about the solution. Let's now move on to the implementation. So guys, as you can see here, I have already imported my reviews table. If I just run this query, you can see that my table has been shown over here. And since we just want to calculate the average rating for each restaurant for each month, so let's start writing the query step by step. So our first step was to extract the month from the submit date column that we just discussed. So I'll just write whatever the columns I want to retrieve over here. So first of all, I want to write the month. So in order to write the month, I'll just extract it using month function. So I'm just applying the month function on my submit date column, and it will give me the month. Next, I want to retrieve the restaurant ID as it is. So just writing the restaurant ID. And the third one is, since I just want to calculate the average rating for each combination of the restaurant and for each month. So I will just use the average function on this. So average function on the rating. So it will give me average rating. So these are the 3 columns that I want to retrieve from my reviews table. I'm just writing it from reviews. And also we wanted to group the data, because since we would like to calculate the average rating for each combination of restaurant for each month. So I will just group the data. I'll just apply the group by clause on the restaurant ID and restaurant ID and month. At last, I just want to apply my filtering condition, that is I only want to include restaurants that have at least 2 reviews in a month. So I will just apply this filtering condition using having clause, that having count of review ID for that combination of restaurant ID for that month should be greater than or equal to 2. So this is all about my query. If I just run this query, you can see that I have got the expected output. There is one more method you can just solve it. If you don't want to use month function, and you can, if let's say the interviewer asked you to use it using extract function, just write the query using extract function. Then you can also extract the month from the submit date using extract function. So I will just help you explain how to write that. So here, let's say I want to use extract function, so I will just write extract month. What is that you want to extract? It is month from submit date column as month, and you can just group by on the restaurant ID comma month, or you can also write, if you just run this, you will get the same output. And you can also write something like group by on restaurant ID and extract month from submit date as it is submit date. Okay, so if you just run this query also, you will get the same output. So let's understand the problem. So assume that you are given a table on Walmart user transactions with the following columns: the product ID, user ID, spend, and transaction date. So product ID is the ID of the product purchased, user ID is the ID of the user, spend is nothing but the amount spent on the purchase, and transaction date denotes the date and time of the transaction made by the user. Now, based on the user's recent transaction date, you have to write a query that retrieves the users along with the number of products they bought. You have to output the user's most recent transaction date, user ID, and the number of products sorted in chronological order by the transaction date. Now, chronological order is the arrangement of events from earliest to latest. So let's understand with the help of input table and output table here. This is your input table, and since you have to output the user's most recent transaction date, user ID, and the number of products sorted in chronological order by the transaction date, so your output should look like this. So let's now just see like how this output has just got derived from this input table. So let's first filter out the rows with the most recent transaction date of each user. Now from the user ID column, you can see multiple user IDs over here and the transaction detail and their transaction details. So if we see for the user ID 123, so if we see for the user ID 123, there are 4 transactions as we can see here. 2 transactions have been made on 8th of July, 1 transaction on 10th of July, and another transaction of 11th of July. So as we can see that the recent transaction is made on 11th of July here. So since we are just filtering out the rows with the most recent transaction date of each user, so we are just highlighting the filtered row in green color, and we are just eliminating the previous transaction dates by highlighting those rows in red color. So this is how we have actually did. Now if we see for the user ID 115, so as we can see the user ID, there are two rows that denotes the transaction details of the user ID 115. One made on the 8th of July and another one made on 12th of July. So as we can see, the 12th of July is the most recent one. So again, we are just going to highlight the same for this user ID. Now we have only one user ID left with the 4 transactions. With the user ID 159, it has 4 transactions. One made on the date 8th of July, second on 10th of July, and 2 transactions have been made on 12th of July. So as we can see, the recent transactions are of 12th of July. So we are just going to highlight the same. So what we have done over here is we have first filtered out the rows with the most recent transaction date of each user. Now we just want to calculate the count of orders based on these users along with the transaction dates. So as we can see that for the user ID 123, only one product have been purchased, which is the product ID 9765. Now if we see for the user ID 115, we can see that again only one product have been purchased on 12th of July with the product ID 6536. And for the user ID 159, as we can see that 2 products have been purchased on this particular date, which is on 12th of July, one with the product ID 7384 and another with the product ID 1247. So our purchase count is 2 over here. So this is how we are just going to find our output. So let's now move on to the steps, like what steps we are going to follow to write a SQL query to get the expected output. You can also pause the video here and think through your approach, like what methods to follow and what approach you're going to apply to get the expected output. So first of all, we are going to write a CTE to find the most recent transaction date for each user. In the second step, we will just filter out the most recent transaction dates. And in the last step, we will just count the number of products for those transactions, and we'll just order the results by date, since we want them in the chronological order, that from earliest to latest. So let's now move on to the implementation part. So guys, here is how the interface of my SQL workbench looks like. As you can see, I have already imported my user transactions table. If I just run this query, I'll get all the records have been displayed. So as you can see that this is my input table, and since you all know that I just want to count the number of products for the recent transaction dates for each user. So to do that, our steps was to actually filter out the most recent transaction dates of each user. So let's move on to the very first step to just write the expected output. So here I'm going to write my query. So I'll just filter out the most recent transaction date for each user, the details of those orders. So here and to do that, I will just make use of rank window function. What the rank window function will do is it will just rank the transaction dates in descending order, and then we can just able to find the details of the orders that have the highest rank. So let's just apply that function over here. So select from, this is my user transactions table, and whatever the columns that I want to retrieve, I'm just going to write over here. So the very first column that I want is the transaction date. Second, I want my user ID. Third, I want my product ID. And at last here I'm just going to apply the rank function. So I will apply the rank function over partition by. So in this case, you are going to apply the partition by clause on the user ID column, since you want to rank the transactions for each user ID here, and since you want to do order by transaction date in descending order, so you're just going to write that. Why descending order? Because you want to give the highest rank to the most recent transaction date. So you can just give the last alias as transaction rank. So this is your transaction rank. Now if you just run this query, what you will get is, you can see that your ranks have been assigned. So if you just see the output very clearly, you can see for the user ID 115, the most recent transaction date, as you can see, is the 12th of July, and it has been given the rank 1. Now if you see for the user ID 123 with the 4 transaction, the most recent transaction date is the 11th of July, that has been given rank 1. And if you see for the user ID 159, you can see there are 4 transactions. There are 2 transactions that are the very recent one that have been made on 12th of July and has been given rank 1 to both. So as you can see that we have assigned ranks. Now what we are going to do is, we are just going to filter out only the recent transaction dates. That means we are just going to apply the where condition, where the transaction rank should be 1. So it will just filter only the rows of only the details of those users with the recent transaction date. So I will just write this query in a CTE. I'm just making it as a CTE with CTE. So I will just give the name of the CTE, say latest transactions as. So I've just plugged it into this CTE and just writing select star from latest transactions, where transaction rank is equal to 1. So what I'm doing here is, if I just run this query completely, so as you can see that I have filtered the rows here. So now I just at the last step here, I just want to count the products for each user based on their transaction date. So at the last, what I want to do is I just want to count the products, and to count the products I will make use of count function on the product ID column. So here I can just, whatever the columns that I want to retrieve in my output. So since I wanted to retrieve the transaction date column, so I'm just writing the columns that I want to be displayed in my final output. So user ID, and the third column was the purchase count column. So here since I told that I'm going to use the count function on the product ID column, so this will display the purchase count. Now there's one thing that we have to note, that we will have to apply the group by clause on the transaction date and the user ID column, since these two are non-aggregated columns, and as we already know that non-aggregated columns always come under group by clause. So group by transaction date comma user ID. So I hope this is your final output. So if you just run this query here, you can see that you have got the expected output. So as we can see that we have output the user's most recent transaction date, the user IDs, and the count of products they purchased based on these dates, sorted from the earliest to we have to sort it from earliest to latest. So to do that, order by transaction date. Now you can see that they have been sorted in the chronological order. So that's all about the solution of this. If you think there is any other approach in your mind, please let me know in the comment section. The question is on identifying numbers that appear at least 3 times consecutively in a table. So let's understand the problem statement first. So assume that you are given a table named logs that stores the following columns: ID and num. So ID is nothing but the unique identifier for each row, and num column contains the number for each log entry. Now our goal is to write a SQL query to find all the numbers that appear at least 3 times consecutively. So this is how our output should look like. So if you see output, we can say that number 1 appears consecutively in the first 3 rows, having the ID 1, 2 and 3. That's why it actually satisfies the condition and it is shown in the output. However, if you see for the number 2, if the number 2 appears consecutively only twice, with the rows having ID 6 and 7. So it does not meet the requirement of 3 consecutive occurrences. Therefore, the output contains only the number 1 as it appears 3 times consecutively, and it meets the requirement. Now that you just understood the problem statement, the input table and the output table, let's see how to approach the solution of this problem. So to solve this, we just need to compare each row in the logs table with the next 2 rows. Specifically, what is that we need to check is whether the current row number should be same as the next row. Also, the next row number should be same as the row after that. So if all the 3 consecutive rows contain the same number, say for the ID 1, for ID 2 and for ID 3, these are the 3 consecutive having the same number. That means we know that the number appears consecutively 3 times. Now the question is how to achieve this, how to solve this in SQL and what function to use. So to do this, we will perform self join on the logs table. So what the self join will do is it will help you compare multiple rows within the same table by treating the table as if there were 2 or more tables. So let's go through the solution approach of this problem. So for the very first step, we are just going to self join the table. So we will join the logs table with the itself 2 times, shifting the ID in each join to compare consecutive rows. Now in the step 2, we will just apply the conditions to ensure that the number in all the 3 consecutive rows is the same. And in the third step, we are just going to select the distinct numbers, since we only need the unique numbers that satisfy this condition. So we will just make use of distinct keyword. So now let's move on to writing the SQL query to implement this approach in MySQL Workbench. So guys, as you can see, I have my logs table here, and since I want to find the numbers that appear at least 3 times consecutively, and to do that, I'll be applying self join as we already discussed. So let's just start writing the query here. So select whatever the column that I want to retrieve, I'll just write it afterwards, and I will do the self join. This is my logs table, and as I already told that we will be doing self join 2 times, so I'm just giving it as alias L1 and logs as L2. So this is the one time that I did self join, and one more time I'll be doing it, so I'll just give it L3. And we will be applying some conditions to just compare the first row with the second row, to ensure that the number in the first row equals the second row. Also, we will compare the second row with the third row, ensuring that the number in the second row equals the third row. So let's apply that condition over here. So where L1.id should be equal to L2.id minus 1. So what this condition will do is, it will just ensure that L2 is the immediate next row after L1. For example, if L1.id is 1, then L2.id must be 2. So here in this case, we just compare the first row with the second row. And we will also compare the second row with the third row. So let's do that as well. So L2.id should be equal to L3.id minus 1. So again, what this will do is, it will just ensure that L3 is the immediate next row after L2. For example, if L2.id is 2, then L3.id must be 3. Also, we have to ensure that the number in the first row equals the number in the second row, and also the number in the second row should be equal to the number in the third row. This number has to be same. So we will have to write the condition for that as well. So I'll just use my AND operator here, and just guys, okay. So and my L1.num should be equal to L2.num, and my L2.num should be equal to L3.num. So in this case, what we did is, the first condition we just wrote it to compare the first row with the second row, and this condition again we wrote to compare the second row with the third row. And then we just compared the number in the first row is equal to the number in the second row, and in the last condition we just compared that the number in the second row should be equal to the number in the third row. So the first and the second condition we actually use to make sure that here in this case the L2 is the immediate next row after L1, and here the L3 is the immediate next row after L2. So we have written our conditions over here to just meet the specific requirement that we have, and we will just here we will just write our column that I just want to retrieve. So here I'll be just writing my L1.num as consecutive nums or num, anything. So here in this case, I just wrote my L1.num because this is only I just want to retrieve. Also, I'll be using distinct function here to make sure that we only need the unique numbers that satisfy the condition. That's why we have just used distinct. So that's all about the solution. Let's just run this query here. And as you can see that we have got the expected output from the sample input table, as we already saw that the number 1 appears consecutively 3 times. So that's all about the solution. I'll quickly explain the solution once again. So in the very first step, we just did the self join two times here, and then we just applied the conditions to ensure that we are looking at 3 consecutive rows. So the condition L1.id is equals to L2.id minus 1 ensures that we are looking at consecutiveness of the rows, ensuring that L2 is the immediate next row after L1, and the condition L2.id is equals to L3.id minus 1 again ensures that L3 is the immediate next row after L2. And here we had to make sure that the numbers are same for these consecutive rows. So here for the rest two conditions, we just made sure that the number in my first row has to be equal to the number in my second row, and again the number in my second row has to be equal to the number in my third row. So I hope you're clear with the solution. So as you can see, we have successfully written a SQL query to find all the numbers that appear at least 3 times consecutively. Also guys, this is one of the most commonly asked interview question. You must know how to solve this question. So if you find this video helpful, please don't forget to like, share and subscribe for more such tutorials. Thank you for watching the video and see you in the next video.